Symposium. Our first speaker for this session is a scholar of remarkable depth and expertise, Professor K. Ramasubramaniam. With a unique blend of Sanskrit, mathematics, and astronomy, he has illuminated India's rich scientific heritage, bringing ancient texts to life with modern relevance. His research on works like Ganita Yukti Bhasha and Tantra Sangra has highlighted India's advanced mathematical and astronomical understanding. Professor Ramasubramaniam has also made significant contributions to education, advising on the National Educational Policy 2020 and preserving ancient Sanskrit manuscripts. Globally recognized, he was honored with the Maharishi Bhadran Vyas Samman, and his lecture on computing pi, the Indian method, has captivated millions. We are privileged to have him with us today to share his invaluable insights on the need for bringing out fresh editions of classic works. Please join me in welcoming Professor K. Ramasubramaniam. Sir, please.
So, namaste to one and all here. So, I am very happy to be a part of this program. Thanks for the organizers. Thanks to the organizers for inviting me. This I will keep it very, very short. So, I am going to talk to you about the need for bringing out some classic works. By classic works, we mean in the tradition, suppose you are familiar, if you are familiar with literature, so Kalidasa's Raghuvamsha, it's a classic work. So, some such thing, I mean in today's parlance, if you want to say, if you are computer science students, the work of Donald Knuth, The Art of Computing, this is considered as a very classic work. So, something along these lines. Before I proceed, I want to show you, for you to have a feel as to how the texts have been transmitted to us, which many of you would not have an occasion to see. ये क्या करना है, राइट ही करना है ना? हाँ, वो कर रहा हूँ. Nothing. Right? Okay. Okay. See, look at this. This is one of the fairly well maintained paper manuscripts where people have been writing. So, there is no scope for you to just cut and then do, etc. So, that kind of a thing. So, this is how people have been writing out. So, here if you look at, so it may not be very easy for even those who are quite familiar with Devanagari to quickly figure out what is being written. And you may not even find any para breaks and so on. So, they will just keep writing. So, this is the way one of the manuscript looks like. Today, so we use all these devices. So, A for Apple, B for Bluetooth, C for chat, D for download, email. So, it is only these things that we are sort of familiar with. You would not have an occasion to see even manuscripts. And earlier, so about 150 years ago, so this is a sort of sketch where you see this Bapudeva Shastri, so a famous traditional scholar as well as a mathematician. So, when he was teaching, people will be just like this, sitting and learning. So, nowadays people talk of attention span of 5 minutes, 10 minutes, 3 minutes, 2 minutes and 1.2 seconds, I don't know. So, this is how things are being done today. On the other hand, even when I started learning, my grandfather used to teach 50 years back. So, we will just sit without any book, we will listen to what he says, we have to just repeat. And this will go for almost an hour. So, this is a certain ability that human beings are endowed with to carefully listen and retain things in mind, which is completely disappearing because of various intrusions of the devices. Devices as such need not be blamed, but we feel that these are not necessary. I have this device, I have even my own students nowadays, notes 20 years back when I joined IIT, they used to take notes. आजकल, I mean, the slides have to be sent and they will just click bhi hai, but we are supposed to send slides and therefore they don't even. So this is another kind of a problem that we face. Anyway, now, so we have this was shown to you only to tell you that when we need to get these things in the form of printed material or digital form today, what are the challenges that we face? That is the thing that I wanted to convey to you. So just imagine, so there was a certain tradition where people have been, even before this paper medium was available, people have been composing. So when Tyagaraja suddenly comes up with a song, so there may be some sishyas who may be noting down, who may be listening, and then they immediately try to jot on, right? So before even the medium was there, people have been creative and they have been composing various things. Now these things have to be stored. So at some point people had this medium to write. So in different places, different medium was there. Somewhere this birch bark will be used, somewhere. So even recently I went to this northeast. So they have a special plant where they will have some nice things coming out and they will write on that. Okay. Sachipat. So this is another thing. Now paper came after that, and even when paper were there, so my grandfather also, they did not have any other medium. I have seen his beautiful handwriting where they will try to copy Siksha Grantha from his own teacher and so on. So this is how somebody copies, the medium will not stay for more than 100, 150 years and therefore it has to be recopied and so on. When such things are being done, so initially from memory to some medium. So memory to some medium, there can be some error. And medium to medium, so it need not necessarily be copied by someone who is knowledgeable, but someone who has been assigned the task. And therefore, when this is done, if he is not careful, there are likely to be errors. Now, what happens in some places, there are conceptual errors, grammatical errors. So most of the things were composed in the form of poetic meters, and this metrical composition, some metrical requirements will not be satisfied. Sometimes you will find typographical, sometimes even verses will be missing. So something would have been left out by that fellow. So in such cases, what do? Omission and commission of words, this happens. Absence of clear demarcation of various sections, verses and so on. So some of them could have been avoided, whereas certain other problems, I will just tell you what happens when you try to bring out a certain edition from the manuscript. So that is the point I want to convey. I will just give you one example now. Here is a famous work. Any of you who have heard of the name of Varahamihira? Yes. What are the works that he has written? He was an astronomer, astrologer and a polymath. Okay. One of the remarkable works that he has authored is called Brihat Samhita. Okay. This Brihat Samhita, for the first time, it has come in the form of a book, paper edition. This happened in 1860s. Okay. Almost 160 years back. So this is the opening verse, Jayati Jagatah Prasutir Vishwatma Sahaja Bhushanam Nabhasaha Druta Kanaka Sadrisha Dashashata Mayukhamala Chita Savita. Savita means sun. Okay, Savita means sun. At the beginning, one tries to pay some respect to one's own desired deity. So here he is praising Savita. And here says, Jagatah Prasutihi means Jagat. Jagat basically means this universe, and anything which is movable is also called Jagat. In fact, those who have studied a little bit of this mantras, Jagatas Tasthusascha Surya Atma, Jagatas Tasthusascha is a Vedic mantra. Jagataha means something which moves. Tasthushaha means that are stationary. So he is the Atma for all of them. Without sun's energy, nothing will happen in this universe anyway. So these things are very interesting. So he describes them. the point I wanted to convey here is, in all the editions which have been printed, we had Malarchitaha was there in printed editions. This Malarchitaha seems to be a problem here. Architaha means someone, you know, Architaha. What does it mean? Worship. Very good. Now, Mayukha Mala, the word Mayukha means Kirana. Okay? Mayukha Mala Architaha, there is a problem. Sun is being described. Okay? Architaha means worshipped by that will not work. But that has been the patha which was found in this Psalm in Sudhakara Dwivedi's edition and another edition. But there was a bit of a problem. So, when we tried to look into this, so we had a bit of a problem, therefore we tried to find some other manuscript which can give a better reading. Fortunately, one of the manuscripts gave this Malachitaha. Now, there is a certain commentary also which is available for this work, where, so Professor MDS can easily see, so what he has done is, in the Sudhakara Dwivedi's edition, he will just put Tayarchitaha. So now this Tayarchitaha, but Utpala calls it as Vyaptaha. So Architaha and Vyaptaha, they never go together. So there is a bit of a problem. So Tayachitaha. So here this was detected. Once this was detected, we felt that there is something seriously wrong, and the manuscript really came to help. And I don't have time to elaborate on all these beautiful things that have been stated here, and we could sort of fix this. This is the first verse. So where there is a serious mistake in trying to understand this issue. Okay. I will just skip this. I will give you one more example. This is another verse which is the fourth verse in the text. This is a little more complicated. So we have to really pay our homage to all those people who have worked in these manuscripts to bring these editions for us. I mean, there may be errors, there may be various factors. But people do not really understand today the amount of effort that has gone in. So when Mahadevan was speaking or somebody else was speaking about this treasure, how was this handed over to us? So it was initially kept in memory by and large, and then there were some medium. And in fact, my own father said he did not have the second Veda book to study. My father can read the book from the other side very fast. Then I asked him, how do you do? He said, when I was a child, so my brother will keep it the other way, we sit opposite to each other and I see from here and therefore I can read from the other side. So what I am trying to say is that was the difficulty with which people have been trying to carefully preserve and transmit this knowledge. This is something which we need to understand and appreciate. Okay, now come to this verse. Kshitanaya divasavaraha na shubhayiti pitamaha prokte Kujadina manishtamiti va kotra vishesho nridivya kritehe. This has an interesting message. We will not get into that. This is called Arya meter. So all this metrical composition, there are some constraints. Suppose you have this Saraswati Namastubhyam. Saraswati Namastubhyam. Varade Kama Rupini. Vidyarambham Karishyami. Siddhir Bhavatu Me Sada. All will have 8 syllables. So this is the kind of thing. But this is not a metrical composition where you count the syllable, but you count the matra. This is a special kind of a metrical composition. Now if you look at this, this has to be satisfying certain count. If you just see Kshiti, Tanaya, Divasa, Varaha. Up to this you will have 12 beats. After that, Nashubhayiti Pitamaha Prokte. If you read this, you will have 15. This will be actually Upagiti. If you have 12, 15, 12, 15, this is called Upagiti. If you have 12, 18, 12, 18, that is where we have this Giti. See, Vyase, Variti, Nihate, they will all be like that. Here, the reading that we found was Kshitita Naya Devasavaraha Na Shubha Kriditi Pitamaha Prokte. So, this is the reading we found. But when we counted this, see, those who are extremely familiar with something, so suppose he is a musician. So, if the Kalyani Raga is being sung, so there is some error somewhere, he will immediately pick up. Right? Similarly, those who are acquainted with these meters, as you read, you will find that there is something wrong. This Shubhakrit actually puts it as 16. Instead of 12, 15, it makes it 16. But 16 is not possible. So therefore, what people have done is, in some editions, Shubhakriditi Yedi, they have just added it. See, Shubhakriditi Yedi Pitamaha Prokte. Then it will be 12, 18, 12, 15. It will fit the meter. But then what happens is, the meaning of Yedi doesn't match. So these two editions, so this Lahore edition and this edition, so they had this patha, whereas some other thing has this, but then that also was not of help. Then another manuscript had this patha, Na Shubhayiti Pitamaha Prokte. So that gives the perfect reading. So it meets the context, it gives the correct meaning, it also satisfies the metrical requirements. So the point I wanted to convey here is, whether I go through many slides or I can just to show you, unless you have several manuscripts with you and you have a very, very careful eye to ensure that the metrical requirements are also satisfied and the meaning is also fitting in, and this requires scholarship in multidisciplines. See, and a very, very careful thing. Okay, so there are various requirements that are essential for a scholar to engage in this kind of studies, and nowadays, so it is rare to find people who are able to engage themselves deeply. It is a very, very challenging job and time consuming job, so in which we need to train people. All that I wanted to say was, so reading these manuscripts is one thing, because many of them are yet to be brought in the form of books. So the kind of challenges that we will have is, so this, the point I wanted to make is, this is a very, very important work, Brihat Samhita, which is actually quoted by so many people, which are studied by people. And at some point, the first scholar, so who did, I will just show you towards the end of that. And there also there are various other pathas. Look at this. This at least you should see how they were writing. This is one of the manuscripts that we consulted. So this is Cambridge University Library. The entire Brihat Samhita is there in 12 folios. 12 folios, 24 pages. The entire Brihat Samhita. So this is how they have tightly written, you see. Where is danda, where is the break, nothing will be there. And they have sort of filled up. So every bit of the manuscript, this is where it will be going inside and coming out. So this is how people have been, see, the reason is, the medium was not available for them easily. So you have to minimize the space in which you have to pack the information. There you have to be extremely careful, so that, I mean, you don't jump from word to word. So from this, nowadays we have all sorts of media. So the other text, important text is Ganita Kaumudi. I'll just take you very, very fast. I'll just slip all this because I have to go. And I just wanted to show you one or two things. Here again, there is some interesting thing. So this Acha Ganakanandakaram Sankshepat Ankapashakam Vakshye Niyatam Niyatam Matsaravanto Dushtaha Kuganakaye. This is one place. This Niyatam Niyatam, so one can try to interpret with a little difficulty. See, Ganakanandakaram means I am going to present to you a certain chapter This Anka Pasha, basically it has to do with combinatorics. Okay, Anka Pasha is a combinatoric. Basically something which has to do number things. Anka Pashakam Vakshye means he is promising that I am going to elaborate to you the procedures that are involved in these combinatorics. Matsaravanto dushtaha kugunakaha ye. See, Matsaravantaha means those who are sort of jealous, etc. See, niyatam, one can with difficulty try to do this, but see this Sudhakara Dwivedi's son, Padmakara Dwivedi, he says, Nipatanti yatra. See, so this, he tries to make some sort of a speculation that this letter would have been interpreted this way. So this kind of a thing is also essential for you to guess what could have been written mistakenly in what form, what may be. So this kind of a guesswork in some places is essential, because if you do not have something. One more point which I wanted to tell you is, this I will leave, just see. Here, Tvaditam amilatam te. So when you combine tan te, so tan te is also tan te. So there are mistakes which can happen. So where you try to combine, and if you try to break it improperly, the whole meaning will go wrong. This is one kind of. Another problem is, see, yat kokilang kulam. See, yat kokilanam kulam. So there will be metrical problem, one guru will be gone. So these are different kinds of problems that we encounter, and sometimes some number will be written as 30 instead of 36. These kind of problems will be there. This also is I will leave this, and I want to show you one interesting thing. See, sometimes this kind of a thing issue will be there. See, so where same verses are just repeated with different numbers, this is a problem. Come here. This is an interesting exercise which me and my students were doing. What happened is, Dvisame vapi trisame. See, if you think of a quadrilateral, four-sided, right? Dvisama means two sides are equal, right? So a rectangle can be considered as a Dvisama chaturashra. Trisama means three sides are equal. Trisama chaturashra, three sides are equal. This is another kind of a thing. Now he is giving some sort of a problem. Okay, Vishama chaturashra means all four sides are different. Sama chaturashra means all four sides are one and the same. It is a square. Now the problem is, Dvisame vapi trisame kathaya sakhe vetsi vadanadin. This is what is there. But where is the problem? What is the number? So the first half of the verse is gone, where the numbers were to be stated, that itself is gone. So they actually give the rule and then they give a problem. This is how the text actually goes. And fortunately in the commentary, when he has worked it out, he said Sukshma phalam, Sthula phalam. So these two numbers have been given. So from this, we try to construct this. See, Yedi chaturadhiko nashatam sthulam sukshmam phalam chaturvahau. So something like this should be there. If we are fortunate to get some manuscript which gives, otherwise, something like this has to be done in trying to get this work back to us. See, so this is an exercise which I knew this problem. Yesterday I was sitting with a student, and there are few more instances like this in the text, where half verse is missing. Okay, they have just copied and then they have left out. And this actually fits in. See, now what happens is, you have to take the number, you have to ensure that the metrical pattern also fits in, and it just gives the whatever problem that has to be posed is posed. So this is another kind of exercise that is required in trying to bring out these works. And there are a few other things. I think I will, this is the last slide, I will just quickly say. So where the scholars have expressed the difficulty which is involved. So if you look at this, so this 1865, I told you, this Hendrik Kern, who was a Dutch scholar, okay, Dutch Indologist who spent basically 2 years in Varanasi, and he came here and even taught in one of the Sanskrit colleges. As he was here in India, in Varanasi, he tried to bring out a translation of the Brihat Samhita. And the problem that he faced is stated in his introduction. You see, I am sorry to say that the copies of Utpala's commentary are in such a condition that I have often been obliged to recur to conjectures. Means I am unable to decipher what exactly was there. Most of them, however, being obvious, some may be obvious, and the uncertainty about true reading materially affects the translation. He was basically engaging himself in producing a translation of this Brihat Samhita, and the want of any explanation on the part of Utpala does so in no less degree. So this is basically the codices that he had did not give him the right text. I mean, this he is saying 160 years back. Now our Pandit Sudhakara Dwivedi, who was a remarkable scholar, so who has written several commentaries in Sanskrit for various astronomical and mathematical works and independent works also. So he says, Etasyaha ekasyaiva adhyayasya samshodhane yavan parishramah tad dashamamshenaiva shramena sukhena maya samagra bharat samhitayaha nutana tika kartum shakyate. So he says, so basically I think he means the second chapter where the Utpala's commentary is huge and Parashara's quotations are also done. So he says, the time that I have spent in trying to decipher what is stated in the commentary with various manuscripts, in 1/10 of it I would have written the commentary on my own for the entire work. Okay? That is what he says. See, Dashamamsha means 1/10 of that. I would have completed the commentary for all the 100 chapters. I mean, that is what he is saying. So the point I wanted to convey is, basically, so this is a very, very painstaking work, and this is very, very essential because some of the things which have been, so Srinivas knows, so when we discuss some of these texts, so we find that there is a certain problem here. So for that, with the available manuscripts that are still surviving, at least some effort has to be launched to ensure that we have the proper text that is available with us. So let alone serious scholarship in that, but getting the text reconstructed itself is a huge task. Some efforts have been put by some people, and what has happened is the printed versions have been taken to digital versions, and the digital versions have far more errors than the printed versions. So that also has not been fixed. See, for instance, you may be knowing, so this Shabda Kalpadruma is a very important work. Vachaspatyam is a very important work. These are all considered as thesaurus. And they have been put into digital form almost 25 years, 30 years back. But then if you look at them, so there are plenty of errors. So it requires enormous amount of time, energy and dedication and scholarship for us to get these classic works at least in error-free form. So this is all I wanted to convey. Thank you very much. I have to go for some other meeting.
I would like to request you to be on stage, please. Thank you so much, sir, for the insightful session on India's scientific heritage. Now I request our Vice Chairman, Sir Mr. Vineet Wirtz, and Professor P.C. Deshmukh, sir, to please present a token of appreciation to Professor. Sir, please.
Absolutely no.
Thank you, sir. So moving ahead with the next session, next speaker, we have Professor M.D. Srinivas, who is founding chairman of the Center for Policy Studies and a former professor of theoretical physics at the University of Madras. His research interests are in the areas of conceptual and mathematical foundations of quantum mechanics, Indian knowledge traditions, especially in science and technology, and Indian society and polity prior to the British rule. In collaborations with K.V. Sarma, M.S. Sriram, K. Ramasubramaniam, and R. Venkateshwara Pai, Srinivas sir has worked on the major source texts of the Kerala School of Astronomy and Mathematics. These texts showcase the seminal work of the Kerala School on calculus and non-geocentric model of planetary motion, which were to become the hallmarks of the European scientific revolution 2 centuries later. Sir has also done extensive work on the epistemological foundations of the Indian sciences. A fellow of the Indian National Science Academy, Sir has also been a member of the Indian Council of Historical Research and is currently a member of the National Syllabus and Teaching Learning Materials Committee set up to implement the new education policy. Please welcome him for a talk on incorporating Indian knowledge in our school and higher education curriculum, the way forward. Sir, please, over to you.
Pranams to all the elders here and greetings to the students. It's rare to see so many students in a talk on Indian knowledge system. So Professor Deshmukh and the organizers have to be really felicitated and congratulated for this. ठीक है तो इसको निकाल दें नहीं आप दोनों लगा सकते ठीक है तो I will try to mostly address the students except for few occasional points. So first is why do we need Indian knowledge systems? Why are we talking about it today? So that is something that our students should know. Then I will say something about how in the higher education scheme, like in the courses that you are studying, we incorporate Indian knowledge. That's for the organizers here to implement. Then in a brief time, because merely talking about Indian knowledge system is not going to be very useful to you, I will give you some overview of what Indians did in astronomy and mathematics, so that at least you will know the names of 20-30 persons. Perhaps you may know the names of 5-6 of them. But you will also know, you will be able to say at least one sentence about what they did. So that's very important. And lastly, I will say something about what we can do in school education, if I have time. So what is Indian knowledge? So Indian knowledge is all the systematized disciplines of knowledge which were developed to a very high degree of sophistication in this country from very ancient times. And all the traditions and practices which the various communities in India, including the tribal communities, have evolved, refined and preserved. So to know Indian knowledge, you not only have the ancient books, but you also have remnants of ancient artifacts. You also have the people who have inherited that tradition and practicing it. So all these are sources of Indian knowledge. Now, till the early part of 19th century, this was the only knowledge that was prevalent in India. Until then, they were actively practiced and innovated upon. There was no period of total stagnation. There were some periods of up and down. They contributed immensely to the prestige of India and immensely to the well-being of our society. And it ensured that India was a very major economic power till early 19th century. So during its long civilizational history, India must have undoubtedly borrowed lots of things from other civilizations. But that doesn't make Indian knowledge a khichdi. It is not a mixture of India, Islam, Christianity, East, West. At the core, it was Indian knowledge all through. It was only in early 19th century that there was a total disruption of Indian knowledge system. And so we are in a situation called, in our own terminology, it's called Sampradaya Vichitra, a discontinuity of our continuous evolution in a certain knowledge stream. But today, we are 200 years away from early 19th century. So during at least the last 150 years, a lot of work has been done by many great Indian scholars and even some foreign scholars also. You heard two names, Henrik Kern and Pandit Sudhakar Dwivedi. Sudhakar Dwivedi edited about 30 to 40 texts of Indian astronomy and mathematics towards the end of 19th century. So it is true that a lot of work has gone on, but what's very important to realize, this not only for the students but all the scholars here, that what we have today cannot be said to be a comprehensive understanding of the history, of the methodology, of all the concepts of Indian knowledge. Because if you just take the history of last 60, 70 years, what we did not know about many disciplines of Indian knowledge, even in mathematics or astronomy, etc., and what we know today, there is a great jump, great advancement. So in that sense, we seem to have missed a lot of what we knew 200 years ago in the course of having discontinued studying it. So why is it so? It's mainly because all our knowledge, what is called our traditional knowledge, or civilizational knowledge, went out of the regular institutions of learning. And even those people who had to do all this work, they had to do it on their own, either individual initiative or at the margins of these institutions. So because most of our knowledge went out of not only institutions of higher learning, it went out of all our schools. A simple example is 90% of the mathematics that we study in our school, arithmetic, algebra, geometry, trigonometry, most of it either originated in India or was developed very systematically here. And the rest of the world had to learn it from India, either in 8th century or 10th century or in 15th century. But when we study mathematics, we study it as a totally alien subject. We don't even know who did what, where did it all come from. Whereas when we study this discipline in later times, we will hear so many names. We will hear the name of Euclid, we will hear the name of Pythagoras, we will hear the name of Newton. So this is the kind of situation. Now, therefore, if we want to say we are wanting to see a resurgence of Indian civilization, it's very essential that we should be very thoroughly grounded in Indian knowledge. And just as we did in all the earlier centuries, we can borrow anything from any other source of knowledge. But our grounding should be in Indian civilizational knowledge, values. Based on that, we are able to adopt, take for ourselves, and even innovate upon. The main reason we are not able to innovate upon modern scientific knowledge is we are not only borrowing that knowledge, we are even borrowing the institutions which are used to organize that knowledge in the way they have done. And most of it will not work for us. And therefore, and we don't know the background of those developments that have gone on there, the motivation by which much of this knowledge is generated. So, for us to be a creative civilization, for us to be called as representatives of Indian civilization, most of our activities will have to be informed by and grounded in. Since we don't teach Indian knowledge as a regular part of our curricula, most of us are not exposed to it, and therefore we are not in a position to creatively bring it into the fore in making any innovations and even update our older knowledge for contemporary needs and purposes. So all this is sort of well known, but we have not acted upon it. The new educational policy was one document which tried to sort of tell us we should move fast in this direction. Two most important things in new education policy, which we are yet to follow systematically, are the two. One is research on Indian knowledge should be among the mandated tasks of all our institutions of higher learning. So still that's not the case. There are 10 institutions here which have a small cell in Indian knowledge system, or there are some departments where some work is going on. But this sort of a position that we need to go to, at least in 5 to 10 years. Second, Indian knowledge should form an essential part, not the whole of, but an essential part of the curricula taught in our schools, colleges, and all institutions. That's also not yet happening. Why am I saying this? Because the purpose of higher education really should be to imbue the youth with values, knowledge, and skills that will help them to proudly and knowledgeably manifest Indian civilization in the modern world. That is, it's not merely to say I'm proud of being an Indian. It's not merely to say our ancestors did all great things. You have to know how they did it, what they did. Then only you can claim to be an inheritor of that civilization. And it's that kind of an education and even fundamental values like the Indian understanding of the oneness of all creation. So this is not something that every civilization in the world can manifest that idea. And therefore, that will not be at the core of the knowledge of all civilizations. So while there are civilizations and civilizations, the knowledge generated by them may be universal in terms of application, but it will not be universal in terms of its acceptability, its values, its purposes. So it's all these factors that make it very, very important for us to realize that we need to make Indian knowledge really re-pervade our society as it was 200 years ago. It's not only about India. Say somebody talked about the dark ages of Europe. So how did Europe come out of the dark ages? We all know Europe borrowed extraordinary amount of knowledge and technology from China, from the West Asia, and perhaps even indirectly from India. But they sort of assimilated it into their core civilizational framework, which was essentially based upon the Greek-Roman civilization and the Christian religious worldview. It was the assimilation which brought into fore what we today call as the modern science, modern social science, modern world order, modern West. And so at the core, modern science and technology is a continuation of the older Greco-Roman and Christian civilizational science and technology in a modern form. Many, many countries in the world in the last 30, 40 years, they have of course adopted, like us Indians, the sciences, even the methods of organizing politics, society, all technologies. But many of them are trying to refashion them such that they are assimilable with the core values of their civilization. They are in continuity with their core ideas and knowledge, especially in social sciences, but more and so in all disciplines. For instance, in the last 30, 40 years, the Chinese have come up with a 15-volume sort of understanding of their own contributions in astronomy. Like that, in every manifestation of their public activity, they would like to link what they're doing today with the way China had developed. There's a very famous Japanese mathematician who has worked on Indian mathematics. So at the preamble of all his work, he puts in his own website something very clear, a very simple understanding. which is perhaps missing in Indian discourse. What is the simple understanding? He says that from the Edo period, which is about 17th century, Japan has been following the Western societies for all knowledge, including science, technology, and social thought. Now, the modern Western development in sciences are based upon the understanding of nature and the approach to nature that modern Western society developed. And in that sense, they can neither be thought of to be absolutely true, nor universal, nor should be the essential component of a future science, like today people were talking of a new meta-science or whatever. And it's therefore very essential that we should, Japan had been traditionally following the sciences and social sciences of China and India, so we need to really know all this. So this is the general kind of philosophy. Okay, now we come to specifics. So the new education policy really mandated that we should know all this. So what did Aryabhatta, Varahamihira, Sushruta, Charaka, Bhaskaracharya, Brahmagupta, Chanakya, Chakrapani Datta, Madhava, Panini, Patanjali, Nagarjuna. So we should learn all that these people did in all those disciplines. These should not only be nurtured and preserved for posterity, but also researched, enhanced, and put to new uses through our new education system. So I wish this happens during our generation. So in following this, UGC tried to organize a scheme for introducing Indian knowledge in higher education institutions. And this, sometime around March, they brought out the guidelines. And what is UGC sort of mandating? That every undergraduate student should at least take 5% of the total mandated credits in, they are using the word Indian knowledge system, Bharatiya Jnana Parampara, whatever you may call it. And at least half of this should be in the part of Indian knowledge which is related to the major field of specialization. So if you are studying commerce, you should know about how India performed commerce, what was the economic thought of India. If you are doing mathematics as your major, you should know how mathematics developed in India, to the tune of at least 2 to 3 credits of your major course. And everybody should take a foundational course on Indian knowledge system so that they know something about what India achieved in every aspect of human thought, human endeavor. So this was mandated and put on the UGC website in March 2023, but has not been yet put into action. For PG programs also, the same thing was mandated by UGC, that 5% of the credits should go in the IKS disciplines which are related to. If you are doing biology, you should study what did India doing. If you are doing engineering, same way. And even about courses which are related to Indian knowledge systems, like we have courses in philosophy, where most students may be studying Indian philosophy. We have courses in music, where most students may be studying Indian music. We have courses in Ayurveda. But even here, and many of the Sanskrit, I think there are about 15 to 20 Sanskrit universities, where most of the disciplines are traditional Indian disciplines. But even here, what has been happening is that most of these subjects have been, there is an attempt to relate most of these subjects and teach them in Western epistemologies and methodologies. It's not that we need not use Western epistemology or methodology, but we have been entirely basing all our studies on them. So even our historical methodology, our looking at this, so many times we say evidence-based. So what is evidence-based? This is an issue which has been very widely discussed in Indian books. The entire subject of epistemology in India, Nyaya Shastra, deals with what is evidence, what are the possible evidences, what will make a statement acceptable, what will make a claim acceptable. So while many of these Western epistemologies may be required, the perspective and the main emphasis of all the courses will have to be related to the basic perspectives of Indian knowledge. So with this I have stopped the broad outline. Now I will give you a brief summary, about 5-10 minutes, of how astronomy and mathematics developed in India. So it all goes back to the Vedas. Vedas are not texts about mathematics. They are not texts about modern cosmology. They are not texts about cognitive science. They are texts about how Indians conceived creation and how humans have to live in this creation to be able to realize their essential unity with all creation. But they have a lot of information from which we can understand how various disciplines developed under this larger philosophical perspective of India. So they have a lot of things about large numbers, factors, fractions, sequences, the decimal place value naming of numbers, which is very unique to India, and the idea of shunya, which is zero, idea of purna, which could be related to infinity, and perhaps to many other things also. There is a lot of observational astronomy in the Vedas. The 27 nakshatra system comes from that. The Vedas have a record of Indians of having observed a star at the point of North Celestial Pole. North Celestial Pole is the point in the sky to which the Earth's axis points. Many times there may be no star there. But in 3000 BC, there was a star which was located there, and the text Taittiriya Aranyaka talks about that star. And it's also mentioned in some Puranas and all that. So that was the original Dhruva that Indians observed. But after about 2000 BC, there was really no star near the point where the north direction, the Earth's axis part points in the north direction. There is no star there. This is because of a phenomenon called precession of equinoxes. Anyway, so we now have a star, and that is called Polaris or Alpha Ursa Minoris, and this has been at the North Celestial Pole only in the last 200-300 years. Similarly, there are instances of texts which talk about 1800 BCE. Then there are many, many ancient archaeological sites which will reveal in their construction, in their orientation, lots of astronomical information that we knew at that time. Now we are beginning to start having texts post-Vedas. This Parashara Tantra has been actually not, the original text is not available, and it has been reconstructed from various commentaries. And the main commentary was what Professor Ram Subramanian was mentioning, what is called Bhattotpala's commentary on Brihat Samhita, which was written in 6th century. But that text is quoting extensively from Parashara Tantra. And so you know, around 1350, we had a system of measuring the motion of celestial bodies, not by Rashis as we know today, but by nakshatras. The 27 nakshatras provided the scale to understand where the sun was, and the 6 seasons, planetary periods, eclipses, all that were discussed in that framework, and many comets were discussed and called, and they are also there in the Vedas. Now we come to the first oldest text of mathematical astronomy, not only in India but in the entire world. That's called Vedanga Jyotisha or Arka Jyotisha. It gives a set of algorithms for computing what is called the Tithi and Nakshatra. I will not explain what it is. Professor Shriram may tell you. By using the method of rule of 3. So using the method of rule of 3, assuming the mean motion, you calculate over a period of 5 years. So this is the first text giving algorithms for calculating the positions of celestial objects. It dated to 1200 BCE. I'm sorry about that CE. This should be before the Common Era. And this is indeed the oldest text of astronomy. Now we can go faster. Then we have the oldest text of geometry. These are called Shulva Sutras. They contain the first statement in anywhere of a theorem of mathematics. And today that theorem goes by Pythagoras' name. But that is stated in Shulva Sutra. It is stated in the following form. The square of the diagonal of a rectangle is the same of the sum of the squares of two sides of a rectangle, which is what you recognize as Pythagoras' theorem. Its first statement occurs about 500 years before or 300 years before Pythagoras in Sanskrit. And that's one of the earliest statements of a general mathematical theorem in the world mathematical literature, though we don't recognize it as such. Just as Vedanga Jyotisha was the first text of mathematical astronomy, this is the first textbook of geometry. Then we have other texts, and then we come to one of the most important texts of India called Panini's Ashtadhyayi. This is at the fountainhead of whatever we do in computer science today. It's a text full of algorithms, and it tells you various rules and whatever you do in a computer program as to how various instructions have to follow one after the other, and how a loop will come, how you have to go out of the loop. All those kinds of techniques are there in Ashtadhyayi. And the purpose of Ashtadhyayi is, of course, linguistic, to derive all words of Sanskrit from what is called the base form and adding pratyayas. Then there is another very great text of ancient period called Pingala's Chandas Sutra. In Chandas, we have only two kinds of syllables, what is called the Laghu and the Guru, the short and the long. And every meter is a sequence of Laghu and Guru. And therefore, you have binary sequences. And so the entire mathematics of binary sequences and converting decimal numbers to binaries and binaries to decimals, and even computing powers and binomial coefficients, there are very, very beautiful algorithms in this book called Chandas Sutra, written in 300 BC. Now still we have finished the ancient period. I will now come to the classical period. The Bauddha Jaina texts have a lot of mathematics. The crucial development of arithmetic was by the adoption of zero into the decimal place value system, and this happened sometime between 300 BCE to beginning of Common Era. So once we had the decimal place value system, we could deal with numbers as we wanted. But now most of our texts were in the poetic form or in the sutra form. So writing number 3560 in a verse or in a sutra or 15,473 will be very cumbersome. So we discovered two methods to use to represent numbers in terms of linguistic phrases. One was called Bhuta Sankhya, where you use something like Netra or I to denote 2, or Veda to denote 4. Another was something called Katapayadi, where the various consonants stood for various numbers. And in fact, this made it very easy to write down entire mathematics or even any other subject in terms of wherever numbers came. In fact, in India, numbers came almost in all disciplines. So these were at the basis of that. Then there are various astronomical siddhantas. And there's something called the Bakshali manuscript, which was discovered in Rawalpindi, near Rawalpindi. This is also a very ancient text. And it's one of the most ancient manuscripts of India. Currently, it's in Oxford Bodleian Library. Its dating has been somewhere between the 1st century to the 4th century. Some of the leaves of this manuscripts are in the 1st century. Some of the leaves of this manuscripts are in the 4th century. But this contains all mathematical symbols, and it's a text of mathematics, and you can see how mathematics in India was being performed in 4th century. Now we come to the actual classical period. The earliest sort of text in classical period is Bharatiya. In 120 verses, he has given almost all of the basic elementary arithmetic, algebra, geometry, trigonometry. He was the founder of trigonometry in 30 verses. And in 90 verses, he has covered the whole of astronomy. Of course, the text is very difficult to understand merely by itself, so there are lots of commentaries on it. In fact, the commentary of Bhaskara 1 has been the one which has made us understand what Aryabhatta did. And there are many more things that Bhaskara did. He also came up with a very beautiful formula as a ratio of two quadratic functions for sine. And this makes sine calculation very easy. It is accurate up to 1% for the entire range from 0 degrees to 90 degrees. It's a formula where sine is expressed as a ratio of two quadratic expressions in the angle. Then the works of Brahmagupta are extraordinarily important because while Aryabhatiya is a very cryptic text, Brahmagupta wrote a very detailed text of astronomy. And in fact, most of our current understanding of Indian astronomy and mathematics is from the Brahmasputa Siddhanta of Brahmagupta. Unfortunately, the most important commentary on Brahmagupta's Brahmasputa Siddhanta is yet to be published and translated. Brahmagupta was the person who discovered negative numbers in a formal sense. Earlier, negative numbers was used in the sense of debt, and even in Chanakya, you have some idea of that. But Brahmagupta gave the rules. -1 into -2 is +2. Or minus of minus is plus, and many other things, and zero also was treated. He started algebra by giving symbols to, instead of x, y, z, he used ya, ka, bha, etc. So algebraic polynomials. And he even discussed very complex equation. I will not tell you what it is. He discussed cyclic quadrilaterals, and he discussed spherical trigonometry. Aryabhatta was the founder of spherical trigonometry. Brahmagupta used entire spherical trigonometry in writing his textbook of mathematical astronomy. So his mathematical astronomy was full of formulae. Only the formulae were written in terms of verses. For the rest of the world to get to all this level of sophistication of astronomy, it took at least 500, 600 more years. It made it possible for Indians to even write other kinds of approximate manuals called Karana. Once you have formulae, you can work out approximate formulae also. Oh, there was this Virahanka, in his work on prosody or chandas, you have these Fibonacci numbers appearing for the first time in 6th century. Now I will rush through. So around 650 is when Indian mathematics went to West Asia. But actually much before that it went to East Asia. I think China adopted Indian astronomy around 500 and Buddhism even 200, 300 years earlier, around 2nd century BCE. In fact, it was observing in the Chinese court that they were using Indian astronomical methods for calculation, that the Baghdad Caliph asked for Indian astronomical texts to be brought there towards the end of 650. So it was the Harun al-Rashid, but his father, I think Mansur, they got Indian text translated. And for about 100 years in the Islamic region, Indian astronomy and mathematics was the primary text. They started translating Ptolemy around 750. But since philosophically their view was more close to the Greek view, they adopted the Ptolemaic text but used the Indian methods of calculation to do all their astronomy. Now we have various books of famous authors, Mahaviracharya, Sridhara, Lalla. Mahavira's Ganitasara Sangraha, he was a Jain in Karnataka, is a work of about more than 1,500 verses entirely devoted to mathematics. Earlier mathematics was with astronomy and other subjects. Prutudaka Swamin Vateshwara, so the list is long, but we discovered the idea of what is called instantaneous velocity of plane. That's a very complicated concept. A car moves 10 miles an hour, so it moves 5 miles in half an hour. It moves, so like that you can go on, but the idea of instantaneous velocity is assuming that for a very short while, how much the car would have moved, you have to find out what its velocity would be when its rate of change of position is not uniform. Similarly, this was a very complicated algorithm, Chakravala, discovered by Jayadeva, which solves a quadratic indeterminate equation, which was rediscovered in Europe in 17th century. But the method that was discovered in Europe was inferior to what Jayadeva had done in 1050. So that's the kind of advances that was there. Bhaskaracharya's name all of you know, but these three texts were the most important texts by being treated as a textbook all over India during the next 500 to 800 years. In fact, many regional language texts adopted what is there in Lilavati and Bijaganita. There were several regional language texts that were written starting around 1100 in the field of astronomy and mathematics. Regional language texts in grammar are known from 600 or 700 onwards. So Mallanna had written a mathematics book in Telugu, which is a translation of Mahaviracharya. There is a Telugu commentary on Surya Siddhanta. Vyavahara Ganita is a Kannada work on mathematics. This is the Tamil work on astronomy. And this is a Prakrit work on astronomy, etc. Now we come to the medieval period. The general feeling is that astronomy and mathematics, everything in India closed around 1200. That's not really true. There was, of course, a certain retardation in the northern part of India because the rulers no longer valued the Indian civilizational learning. But that doesn't mean that Indians gave up their system of education or system of learning as long as that was not actively disrupted by the rulers. So there is a continuous tradition of work in North India also. Narayana Pandita's Ganita Kaumudi, which Professor Ram Subramaniam talked about, this is about 4 times the size of Lilavati and it has 4 times more the content. And he did some things which are very closely related to calculus, like what is called repeated summation. He worked on combinatorics of permutations, combinatorics of binomial coefficients, which were all treated only in 18th, 19th century Europe. Then a whole lot of astronomers who started writing older books. The older books were somewhat short. So the way the teacher taught them must involve a whole lot of explanations and proofs and all that. But we do not have those commentaries. But we now have for Bhaskaracharya various kinds of commentaries written by these people which give very detailed explanations and proofs. We also started taking various inputs from Islamic astronomy that you can see in the works of Nityananda Munishwara. But the most important person in North India was this great person who may really be called the Renaissance person in Indian history in recent times, Savai Jaisimha. He built these 5 observatories in Ujjaini, Delhi, Mathura, Varanasi and Jaipur. Mathura thing was destroyed in 19th century. The Delhi one is used for conducting demonstrations today. Jaipur is a very nice observatory which you can go and even see today. But the Banaras one is in a sort of very dilapidated condition. It's in that Man Mandir Ghat, you have to go around and see. But these observatories were the most accurate ones. They were accurate to 1 second of a minute. 1 minute of arc, that is 1/60th of a degree, which is the best accuracy you can obtain by naked eye astronomy. That was the kind of accuracy that was there. He got works from Persian translated. The Ptolemy's work was also translated from Persian, but he got the French tables of De la Hire translated, and then he used them to do observation with his observatories, put them to observational test. And he wrote to these Jesuits saying, I am finding these discrepancies in your tables. So I don't understand that. Maybe I have not understood what it is. You come and explain it to me. So he was trying to redo the older texts of India by borrowing some of the elements from whatever others had done and putting all that to observational test. This is the most important part of most science, that there has to be observation. There has to be sort of interaction with what can be called advanced knowledge all over the world. But all that with a view to update our own knowledge in such a way that whatever we finally arrive at is in consonance with what we observe and what we need. In that sense, Savai Jaisimha was a very great man. Now I come to the other section, this last 3 minutes only. I'm very sorry I've taken more time. So this is what is well known as the Kerala school. It was started by this person called Madhava. And he, around 1350 or 1370, he discovered this infinite series for pi, sine and cosine functions. Not only did he discover them, he also found out very close approximations for them. He also improved what is called the Vakya method. Then he also wrote on spherical astronomy. His student Parameshwara is known for 55 years of continued observations. And Parameshwara's student's student, Nilakantha Somyaji, was the person who came up with a revolutionary change in the planetary model that was used in India. And this change was such that it made the Indian calculations computationally to be the same as what came about in Europe 200 years later in the models of Kepler. In fact, his computational model was better than that of Copernicus and Tycho Brahe. It was as good as that adopted by Kepler in early 17th century. But it was not revolutionary in India because he explained his model in relation to the older model and the observations he had made in such a way that the transition was very smooth. There was no debate in India whether sun was the center of the world or earth was the center of the world. We knew that such questions cannot be merely answered by speculation. If at all we have to say something, there has to be an observational basis for it. And then this text in Malayalam is the lecture notes of all these people, and that contains very detailed exposition of explanations and proofs. It was written in 1530. It's called Ganita Yukti Bhasha. So regional language literature is not merely a transcription of Sanskrit literature. Many times it has something extraordinarily original, like this text Yukti Bhasha written in 1530. The Kerala school continued. Of course, as you know, the Kerala course became infested with Portuguese and Dutch by about 1500, and by 1550, this learning slowed down, but it continued till about 1819, when actually most of Indian learning really started coming down. When British did a survey of Indian indigenous education in Kerala, they found almost about 600 to 700 students studying advanced mathematical astronomy. And most of them came from diverse communities. And this was the kind of development. The last two slides. These are the history of exact results of pi. And you can see these series that Madhava wrote down. Many of them have been repeated 200 years later in later discoveries. And this was a very seminal work of Ramanujan, which is very similar in spirit to what was done by Madhava. And it was revolutionary in its time. It was used to calculate pi to 1 billion places around 1980. Similarly, in the history of planetary models, you can see this continued development from ancient India. And Nilakantha comes somewhere here, and what he did anticipates what Kepler did. So to conclude, Indians were not wanting to do what Westerners did later. That's not the way to look at it. Or Vedas are not written to tell us how to advance modern cosmology or modern theories of cognitive science. That is not the purpose for which they have been written. So we have to first understand the larger purposes for which it is written. In practice, it may have many inputs. Like the benzene ring, I am sure you remember that Kekule discovered it during his dream. Or it is said that the person who discovered periodic table, Mendeleev, he saw this Varnamala, and it again occurred to him in a dream that the elements can also be put there. But the Varnamala, A, I, E, and Ka, Kha, Ga, Gha, Nga has nothing to directly to do with the periodic table. So we can always derive ideas from our own civilizational resources. But that we can derive only if we happen to know them. But more than that, our civilizational resources tell us the essential civilizational values, the purposes for which we did many of these practical things, and the way we achieved them. With the practical things, the good thing is we would have abandoned if it didn't work. So only whatever worked got passed on, researched upon, expanded upon in thousands of texts on Indian knowledge that's available in India. And I think that will be the purpose with which we should look at them. And that will be the purpose with which we should interact with modern knowledge and go on adding to our corpus so that we can talk of an Indian school of science, if not an Indian civilizational science, in the next generation or two. Thank you very much. I'm sorry for the time I take.
Thank you, Professor Srinivas, sir, for an enriching talk on the contributions of ancient and rich heritage of Vedas and Upanishads on our Indian knowledge system. Now I request Mr. Vineetwat, sir, and Mr. Uday Birje, sir, to present a token of appreciation to Professor Srinivas. Sir, please. Thank you, sir. So our next session, which will be online, and I welcome Professor Shekhar Mande, former Director General of CSR and Secretary DSIR, for the next session, who will be joining online. Professor Mande's journey spans leadership roles in India's scientific community with a strong academic foundation in molecular biophysics from the Indian Institute of Science and postdoctoral research from the Netherlands. A renowned structural biologist and X-ray crystallographer, his research on mycobacterium, tuberculosis proteins, and protein-protein interaction is widely recognized. Professor Mande has been honored with the Shanti Swaroop Bhatnagar Prize and numerous other prestigious awards. Please join me in welcoming Professor Shekhar Mande for his talk on History of Biomedical Sciences in India.
Thank you very much.
Thank you, sir.
I hope you are able to see my slides. Would
Yes,
someone
sir. Yes,
confirm?
sir.
And to just confirm, please, that you are able to see the next slide.
Yes, sir.
Okay, thank you very much. First of all, my apologies that I am not being able to present there myself in person. I would have loved to be there, but prior commitments here did not allow me to be present amongst all of you today. Secondly, I would like to thank the organizers and especially Professor Pranav Deshmukh for this opportunity to speak at this symposium on Bharatiya knowledge system. And thirdly, it's my enormous privilege to be speaking immediately after Professor Ram Subramaniam and Professor Mandyam Srinivas, because both of them are highly learned scholars of Bharatiya knowledge systems, and I consider it to be a personal privilege that I am speaking immediately after them. What I would like to talk to you is about taking example of biomedical sciences in India through centuries, but the kind of narrative that I have been trying to generate, whether I am wrong or right, I don't know, but the narrative that I have been trying to propagate amongst the students is that the knowledge about human health and the medical system has been very old across different cultures around the planet. And this knowledge, there has been a definite way of sharing among many different cultures. Because India is a very ancient culture, our history is full of development in biomedical sciences, and European travelers have taken many of the clues from us to Europe to understand human health there. Now, this tradition of exchange of knowledge has existed till roughly about 17th or 18th century. And since then, when the colonialism took over, the sharing of knowledge rather became skewed, and in fact, we were told that ours was actually not based on the rational thing or whatever, and that's where the conflict between the East and the West really arose. And that's the kind of narrative that I would like to tell you today with evidences about what kind of knowledge existed in India about human health and in general about biomedical sciences. So what I would like to tell you to begin with initially is about the ancient practices in ancient India, medical practices, then how the healthy exchanges between European Indians took place on these practices, and what were the kind of learnings that European travelers took from India to Europe. And then I would come to the modern times in the last 100 years, that what are the notable contributions from India in the modern times, and then I will conclude, and hopefully I will not take more than about 20-25 minutes in all of this. So let me start from our ancient Vedic period, and all of us know that our four principal Vedas are Rig Veda, Atharva Veda, Samveda and Yajur Veda, and the four of them together describe roughly 300 medicinally useful plants, right? So this is a very useful knowledge about medical plants in the Vedas themselves. And from there arise a few hundred years later, or maybe 1,000 years later, two ancient texts which are actually considered to be sacred in the medical sciences are the Charaka Samhita and the Sushruta Samhita. And the Sushruta Samhita talks largely about surgery and medicine, while Charaka Samhita describes many plants and other things. Now, according to ancient Indian wisdom, the whole world is made up of 5 essential, what we call elements, or Panchamahabhutas, the Prithvi, Jal, Agni, Vayu and Akash. All of you are aware of this. And the system is such that we maintain a balance among all of this. And our system of health also recognizes these 5 elements, and we say that a proper balance among the 5 elements has to be maintained. And at any point of time, there is an imbalance, what you would get is some kind of manifestation in a disease-like condition. And that can be recognized by three principal qualities that what we have associated with each person, called Vata, Kapha and Pitta, Vata, Pitta and Kapha, and I will not go into the details of this because this is not a topic of my lecture today. But what I would like to present to you now are based on these concepts that we have developed, what are the kind of archaeological evidences that actually confirm ancient Indian knowledge. And let us go to some of the archaeological evidences based on this. So the first of the archaeological evidences that I would like to present to you, and all of the work that I present to you has been peer reviewed in all the international, many visible international journals. This paper is from the journal called Nature, many of you are aware of this, in 2006. And what they had found out, in roughly about 5 to 6,000 BC in Mehergarh, a few hundred kilometers north of Rawalpindi, certain skeletons that were excavated from Mehergarh, and in these skeletons, from 9 adults, they were able to identify 11 drilled molar crowns. And what essentially it means is that dental surgery in India at that particular point of time, that is about roughly 5000 BC, was quite common. And what they found was the drilling was essentially in the first and the second molar, and the holes were roughly about 1 to 3 millimeter diameter and about half to 3.5 millimeter depth. Now, based on this knowledge, when a few thousand years later, when Sushruta wrote Sushruta Samhita, he actually wrote the entire anatomy, the entire human anatomy, and in fact, he also wrote down procedures for doing on human body so that this can be actually done for correcting any of the abnormalities in human health. So this is the archaeological evidence, and this is full of archaeological evidences in the dental surgery from that period onward, and multiple people around the world have recorded this from the skeletons that they have found out from the archaeological excavations around. And there is a continuous tradition of that till even today. The second example that I present to you is for the exchange of knowledge between Europeans and Indian on medicinal practices, and I will give you a couple of examples on this. And to begin with, the first example that I would like to give you is on what today we call as either plastic surgery, or what has been known in the medical terms as reconstructive rhinoplasty. And the reconstructive rhinoplasty is explained in detail in Sushruta Samhita, and essentially what it says is that you take leaf of a tree, and if you have a nose which is amputated, then we place it on the nose, cut the leaf in the shape of the nose, and then put the leaf on the patient's cheek or forehead, and then a skin is actually excised out of that, is flipped, and the nose is reconstructed. Now this has been known, and for the first time Westerners saw the procedure being operated on an Indian patient was sometimes in 1793. In that period, the British East India Company, they had a camp in Pune, and they had gone an offensive against Tipu Sultan in Mysore, and a bullock cart driver called Kausaji, whose photograph is shown here. This photograph is taken from the Wellcome Trust Library in London. Kausaji was sent as a bullock cart driver to carry ammunition as well as soldiers from Pune to Mysore. And at that time his nose was cut by Tipu Sultan's forces. British of course lost the battle. Tipu Sultan eventually lost the battle to the British forces a few years later. But the 1793 battle, it was won by Tipu Sultan. And as soon as Kausaji returned to Pune, a reconstructive rhinoplasty was actually performed on him in Pune under a tree. And British medical officers and the soldiers gathered around that tree to watch that surgery with great intent. And eventually, about 20 years later, this particular procedure was presented in the Royal College of Surgeons by British doctors, what they had witnessed in India, and based on the account that what they had seen, the first reconstructive rhinoplasty in England, in UK, was performed on 22nd October 1814 based on the precise description of how it was done in India by a doctor called Joseph Carpue at UK hospital, at UK in the York Hospital in Chelsea on His Majesty's Army Man. And Joseph Carpue is on record saying that the operation was reported to have lasted only 15 minutes and the reconstructed nose had every appearance of a natural nose and the forehead took 3 months to heal. Joseph Carpue also notes that, of course, the patient was under enormous pain because of what was going on, which is understandable, but possibly one minor detail that was missed by the British medical practitioners was in India also sedatives or painkillers were used prior to the surgery, right? And most of these painkillers were essentially cannabis based. But I'll come to the cannabis story a little later. So this is the practice that was learned from India, was taken to the West, and today reconstructive rhinoplasty with minor modifications of what I have described to you is practiced in leading hospitals all over the world, including India. The same practice where instead of leaf, one actually reconstructs the shape of a nose, puts bamboo sticks in the nostrils so that the nostrils remain open, and a skin from the forehead or from the cheek is cut, flipped over the nose, and the nose is reconstructed. Exactly the kind of practice that was described in Sushruta Samhita is followed all over the world even today. Now, these are the kind of healthy exchanges between the West and the East that I was talking about, how we are all learning from each other's experiences on this. One of the first earliest examples of the exchanges between the West and the East was in the systemization of Indian medicinal plants. And the foremost name in this is that of a Portuguese governor called Garcia de Horta, who was placed in Ahmednagar, who was the chief physician of the governor with Nizam Shah I at Ahmednagar. He wrote a textbook which became very famous, and it was then translated into 22 different languages very soon. The textbook was initially written in Latin, and many other aspects were recorded in this, how medicinal practices are followed in India. For example, one of the myths that European had carried till that time, that tamarind grows on a palm tree, and he dismissed that particular myth and he records this in this particular book. This particular book also says that there was first recorded autopsy on a cholera victim. He also records that the botanical treatment for a snake bite is because of dhatura extracts. So these are the kind of things that are recorded in this text, and Garcia de Horta was essentially a pioneer to take Indian medical practices to the West in this form of this very extensive text. It was close to about 1530 or 1560 or something around that particular point of time. And as I said, the whole of West appreciated this particular thing and was translated in many Western languages. But another very useful example comes up, and many of you are aware of this particular example, is in the form of Hortus Mulbaricus document that was created by the Dutch governor at a particular point of time called Van Reed. So Van Reed was placed in Kerala, and in Kerala he was amused by the medical knowledge that existed and the use of herbal extracts in treating different health conditions. And he took help of one of the chief of the local traditional physicians, Itti Achyutan, and along with Itti Achyutan, he traversed entire Kerala on foot and collected many plants and recorded that very meticulously in Hortus Mulbaricus. This was the first ever attempt being made in the world to systematically categorize plants. Remember, the students of biology are aware of the Linnaeus classification that was published in 1753. Hortus Mulbaricus of Hendrik van Reed precedes that by a few decades. So, once again, Indian medical practices now were being documented by the Western people. But one of the most remarkable examples is that of the practice of variolation. Now, variolation is some form of vaccination. Many of you are aware, the modern vaccines, the narrative generated by the Western people was the first person to generate a vaccine was Edward Jenner in the year 1797. That's the narrative all of us have read in our textbooks. But the practice of variolation in India and in China has existed for at least 500 years before that. Now, what is variolation? Variolation essentially is to prevent the epidemics or the pandemics. A pandemic like what we saw very recently in form of COVID-19. But then, in the 15th and 16th century, one of the major problems was smallpox. And in fact, it is recorded by mid-17th century, smallpox had edged out bubonic plague as the leading cause of death worldwide. In 1721, there was a deadly outbreak of smallpox epidemic in England, and the doctors in England who had practiced Indian medical practices, who had studied Indian medical practices, they began inoculating on a similar basis what had been learned from India and China centuries earlier. And this was actually described once again in the Royal Society, Royal College of Surgeons in their thing. And one of the records is that by Robert Holt in 1730s, but a more detailed record is by J.Z. Holwell, who was one of the survivors of the Black Hole tragedy in Calcutta, but he made a presentation in 1767. This, mind you, this 30 years before Edward Jenner's vaccine. And in his presentation, he says that variolation was considerably less risky than contracting the disease naturally. The mortality rate, the people who died of virulated patients, was approximately 1 to 2%, as compared to 30% mortality rate those who had not received variolation by smallpox. So remember, those people who did not receive, about 30% of those people were dying of smallpox. Those who had received variolation, only 1 to 2% were dying of smallpox. More than that, variolation was less likely to result in common side effects such as blindness or serious disfiguration. If you are virulated, the side effects were less. And like naturally contracted smallpox, it conferred lifelong protection against the disease after the patient had recovered. And unfortunately, soon after Edward Jenner's vaccine in 1797, which was based on cowpox, that's where the conflicts between the East and the West began to arise. Because by then the East India Company had more or less set a firm foothold in India, and the Indian population was now being forcefully vaccinated with the Jenner vaccine, while the Indian academia or Indian physicians then, they said that we have practiced variolation for ages, for centuries, and why should we actually go for this kind of vaccination by Edward Jenner? So that was the first of the conflicts that arose, but later much more serious conflicts arose, as you are aware, with 1830s and all, when Macaulay started talking about something else. I would like to very quickly come to notable contributions from India in modern medicine. I will not take too much time, I will take less than 5 minutes about this. Because the narrative that was being generated was Indians were only snake charmers, Indians were only magicians, and Indians would treat people by magic rather than any rationality. There were many people who took up in Swadeshi spirit, in the nationalistic spirit, the correct narrative that had to be generated. And one of the foremost of the people who wanted to generate a correct narrative was none other than Acharya Prafulla Chandra Ray. And he was of course a chemist, and he wrote the very classical book which is available on Amazon even today. If you do Amazon and look for History of Hindu Chemistry, you will see that from the earliest times to the middle of the 16th century AD. And he writes in very detail about how chemistry was known, work of Nagarjuna and so on and so forth, how it was actually known in ancient India. And then he founded the Bengal Chemicals and Pharmaceutical Works in 1901 to promote Indian industry and promote Indian practice of medicine amongst people. But closer to today's time, one of the first clinical trials that was conducted in India was by Lieutenant Colonel Ramnath Chopra, who was funded by the Indian Research Fund Association for clinical applications of Sarpagandha in 1930. Now, Sarpagandha is an extract, Reserpine is an extract from Sarpagandha plant, And through proper clinical, modern clinical trial, he showed that this is a very effective hypotensive. Hypotensive is the sense those who have high blood pressure, if they take reserpine, the blood pressure comes down. And it so turned out this was the first drug developed to treat hypertension ever and approved by FDA in 1955. So in true sense, modern medicine had arrived with the work of Lieutenant Ramnath Chopra in India. Ramnath Chopra went ahead to write India's Drugs and Cosmetics Act in 1940s, and unfortunately he did not pursue further, and reserpine then eventually was discontinued because of psycho effects of this particular drug. And those who studied this psycho effect of the drug, the foremost of them, Arvid Carlson and Bernard Brody, who extensively studied the action of reserpine, eventually got Nobel Prize for neurotransmission later. But another name that comes in mind is that of Upendranath Brahmachari, who studied drug to treat leishmania, and this was urea stibamine in 1920, and with that, the death rate due to leishmania came down dramatically in West Bengal and in Bihar in those particular point of times. In the post-independent times, there are many names. I have just chosen only one example, that of Nagarajan, and I want to actually show he was one of the finest medicinal chemists in the Sibagagi Foundation in Mumbai, and he synthesized many compounds, and two of the compounds were shown are here 31 and 32 are what you see here, and this particular compound has recently been introduced in the treatment against TB, tuberculosis, all around the world. It is called protaminid. It was undergone clinical trials and is a fine example of the drug that was discovered in India and eventually made to the market all around the world. I don't want to take much more time. I just want to actually say the last one particular thing that I had mentioned earlier about cannabis. Now, cannabis is described in Atharva Ved as one of the 5 holy plants, right? To the 5 kingdoms of plants which Soma rules as Lord, we speak. And the 5 plants are Darba, hemp, barley, mighty power, may these deliver us the wood. Cannabis has been used in India for long time, many centuries, by many different people. And it has fantastic pain-killing properties. Unfortunately, in 1985, India undercame tremendous pressure by US government to ban cultivation of cannabis. 1985. And then India actually banned cultivation of cannabis, and there also stopped research on cannabis, which was about to take off at that particular point of time. As it turns out today, 40 years later, many states in the US have lifted the ban on cannabis, and in India also we have started slowly lifting. Some states in India, especially Uttar Pradesh, Manipur and all, they are slowly lifting ban on cannabis. And I am very proud to say that while I was in Delhi at CSIR, we undertook one of the studies to clinical effect of vaporized cannabinoids on breast cancer genetic expression patterns in perioperative period. That is, for people who are terminally ill, to give them a very effective painkiller, and we believe that these cannabinoids actually will form very effective painkillers as against the painkillers that are given today. And we do hope that these results would be very useful for the coming times. I would like to end here. To summarize, I have said that India has had a very rich tradition in biomedical practices. There is a very healthy exchange between the East and the West upon these practices, and a lot of knowledge was carried from here to the West. I give you an example of reconstructive rhinoplasty, but many other things actually were carried to the West from here. The conflict really began with the ascent of colonialism, that is in late 18th, early 19th century. And when the West actually started looking towards India in great disdain as their colony, and that's where the conflict began. And the arrogance of colonial powers, and I don't say much, but about later on the barbaric behavior of the colonial powers essentially suppressed the knowledge that has existed in India for a long time. Today, both the West and the East have much to learn and gain from each other. And in this particular manner, the World Health Organization has recently announced setting up a global center for traditional medicine in Jamnagar. I believe that's a very, very welcome step. I do believe that if we go back to our roots and try to understand the practices that have existed in India, which have essentially arisen out of observations and practices on different people, on human beings, I think we have much, much to learn and we can improve human health in the coming time with that. I would like to thank all of you. I would also like to thank Dr. Anand Deshpande and Department of Science and Technology for supporting me in Savitribai Phule Pune University and the National Center of Cell Science in Pune. Thank you all very much once again for patiently listening to me.
Thank you, Professor, for your insightful session and for sharing your extensive research on historical evidence of Indian medicinal plants, medicinal drugs, and practices. So please, you can.
We are slightly behind the schedule. Shekhar, sorry we delayed your talk a little bit, but it was an amazing talk because it was an eye-opener. Wonderful to learn that we knew about dental surgery, reconstructive rhinoplasty, so many things that you narrated with so much evidence of a marvelous talk. Thank you very much. There is a memento for you, but we will hand it over to you when we have an opportunity to meet you in person. Thank you very much.
Thank you, sir. Now we are delighted to welcome Professor Avinash Chandra Pandey, the Director of Inter-University Accelerator Center. Professor Pandey has held several prominent roles, including Director of the Institute of Interdisciplinary Studies at the University of Allahabad and former Vice Chancellor of Bundelkhand University. His contributions to the establishment of research centers and facilities like the Nanotechnology Application Center have greatly advanced academic research. Now please join me in welcoming Professor Avinash Chandra Pandey for his talk on decoding the units of measurement in ancient India. Over to you, sir.
So thank you very much for giving this opportunity. I have my teacher in front of me, Professor M.S. Shriram, who gave a wonderful talk long ago, and that motivated us to go through some of the things which remains to be answered. So in the morning session we had a good talk in which about architecture, about the dams, about longest surviving fort, the musical pillars. So what is the basis? How they can go to that perfection? Unless otherwise the concept of meteorology, the measurements were not known to them, it would have been next to impossible. So I'll give you some of the ideas, and I know that this session is delayed by 45 minutes, so I will try to compress. The only thing is, to youngsters, I would like to showcase that what were the different kind of units that were used and what precision in measurement was actually practiced, and they have perfected to a level that they could achieve so many, whatever we see in terms of marvels, we can look at because of those things. So I'll not go in those details because when I go again and again through Shruti, Manan, and last time Dr. Ram Subramaniam asked me a few questions that what is Yojana, how can you say that this Yojana is universal, something like. So again, I have to go again and again, and this is the process by which our knowledge progresses. And Professor Srinivas was talking about why we need to have this ancient knowledge system, the Bharatiya knowledge system to be known. So I take analogy that if you don't have your roots connected to ground, then you are a bonsai. So you cut your roots, you grow abnormally, and that is a form of art practiced in Japan. So after the advent of Britishers, we all became some kind of bonsai. We would have grown a much larger, longer, taller tree for showing the path of leadership to the world. So that is what requires, and whatever cognitive abilities we develop over a period of time during the civilization progresses, it is only possible when we are again rooted to the system. So that is what the process, and it is already talked about by Professor Ramasubramaniam. He gave some of the issues, how we have the ancient texts, the primary sources, and then secondary sources, and how many perturbations are there inside. So the challenge is how to get rid of those perturbations. So we are actually sometimes, we have access to the secondary sources, and sometimes secondary sources, the interpretations what we find is not correct. So you have to refer to the original text, that is Vedas, Upanishads, and many other texts, which is very difficult because all they are cryptic, and to decipher the meaning, to interpret is a challenge. But if I talk about metrology, this concept is quite old. One example is Manusmriti, and also this was practiced by Chanakya in his Arthashastra, Kautilya Arthashastra. There is one chapter that talks about the importance of measurements, why we should have a standardization of measurements so that no cheating is there, the trade becomes is facilitated with the help of these measurements. So these are many such things, and we all know we start learning physics with the chapter on the measurement. So why can't we go through our own ancient systems wherein this was perfected long back? And there are many other issues. Sometimes we are connected not only to the texts, but also we are told that somebody else came from outside. The history is also distorted. The Aryans, they came, and then the Vedic period is not yours. This is all like, so that should also be kept in mind. And these are some of the things which gives you the intent, why I am keeping all these things here. Today in the morning, Dr. Iyengar from IIT Ropar, he talked about two more Vida, domains of knowledge, which is generally considered pseudoscience. They are all sister disciplines, be it Vastu Shastra, be it Ayurveda, be it your another important thing is we call it astrology, the Phalit Jyotish. But in the back end, you have many such things which are based on observations, meteorology, the measurements. So these are some of the things which need to be understood. He referred very rightly that Vastu Shastra means that you should not have a window on this side or that side. But we forget that the concept of Vastu Mandal, we are bringing harmony with the nature and also bringing all the good practices that an architect should possess. So these are some of things which are there. So we have to integrate all those things. These three sisters are to be not ignored. They have to be looked at from a perspective that what knowledge they have and how they are useful. The other challenge which was referred today by Dr. Ramasubramaniam, that many traditions were there which is just like becoming extinct. The way organic species are getting extinct, the languages, the dialects are getting extinct, the way the different branches of the knowledge, they are also getting extinct. So to catch hold of the scriptures, and also those who know the language in which those scriptures are there, that is another big challenge which need to be understood and should be given importance. And it is all myth. Aryans they were not the people, those who made us civilized. And there are many such theories are there. What is our extent, where the Vedic period is there. So these theories, they serve a different, because I have to, I'm trying. I'll leave these slides with Yeah, I know, but the time is short. We are running behind the schedule, 45 minutes. I am covering that time by reducing my talk. I am giving only those important points which people should know. These are all like standard available things. This Indian theory, when we had the DNA-based studies, we found that this is a myth, and the genetic pool mix suggests that nobody came from outside. These is all our people who have grown, who have contributed to the civilization. Again, some kind of perturbation is there that how this caste system came out of that, how can you correlate it with the genetic sort of, these are all like making you think otherwise. But these studies are now potently suggestive that nobody came from outside. We are all people native from this place. There are many other issues which need to be understood, and that is we should date. When we say something that it is in these texts, so Dr. Srinivas gave a very vivid historical development of several things. So many such things are there. We need to put in right perspective by having a systematic study. The chronology should be established. The dating should be done. And you might have seen today, remember that Brihat Samhita and also the text which Dr. Ram Subramaniam showed, the paper on which the text is written. How old is that text? Which era this text belongs to? How it evolved? So now the technique is there. We can always employ those techniques and find the correct dates. So these are some of the things which need to be looked at. The only thing is that we have to ask why this civilization has reached to such a lofty level several millennia ago and that got depressed. We all know the reason, because of the colonial power, because of many such things, because of disconnect to those sources, because of Sanskrit taking back seat. These are some of the things which should be the reason. And then the script, sometimes they are also not properly deciphered, and these are all the missing dots, missing connects which need to be studied. And now the emphasis there on Bharatiya knowledge system, so it is right time that we should also look at all these issues. So you know, these are the places where the civilization flourished. Very recently we have found another place next to Madurai, that is Kiladi is there, and these are the places where we get remnants. You have seen Shekhar Mandeji, he was speaking about how these molar teeth were found, the drilling was found, the ancient surgical practices were found. Likewise, for measurements, the way you use different scales, those scales were also found on those places, and they are not differing from one place to other place. They have uniform graduations on those scales. So if you go by, and then the names are also changed. If you look at the original sources in Rig Veda, you will find many rivers which were flowing at that point of time. They have now changed their name, but we can always associate with them that at what time. For example, Saraswati. Saraswati is missing now. But at one point of time, Saraswati river was in existence. In Prayagraj, Allahabad, it is a confluence of three rivers where you can see only two rivers, Ganga and Yamuna. Saraswati is not found. But now, with the help of geochronological data, the techniques of accelerated mass spectrometry, we are trying to establish and also find the ancient paleo channels which are actually remnants of that Saraswati river. So they also give a good idea about how our civilization was flourishing and what was the spread of our civilization. That is all given in the original texts, which may have found a different name in coming centuries after that. Original texts are there. And the symbol of Shiva is continuity of civilization. You'll find everything. I'm not going to again give the details. you see the moon, you see the Ganges, you see the ox who is there, right? So when the domestication of animals was there, and then all the ganas, they symbolize that there is a continuity of all the civilization that came one by one. So that is again a kind of, हम जिसको बात करते हैं ना कि लाक्षणिक अर्थ उसका है कि कहीं पर कोई सिंबल है तो उस सिंबल के पीछे उन्होंने कोडिफाइड इंफॉर्मेशन रखा हुआ है कि ये इंफॉर्मेशन आपको इस प्रकार लेना है. Now it is up to you that how you decipher all those things. So this is all the significance, and these symbols are also found in all those excavations in which you can see a river flowing from rivers, Nandi the bull, tiger, the skin which he wore. It was the ancient, everything is in one go. You'll find showing the continuity of culture in one such symbol of Nataraj. So I'll go to the first part, the length, how we used to measure, what was the metric. So you would have studied MKS system, FPS system, CGS system, but in our system we used to measure the length by hand and also with the help of angul. Angul is, you say anguli, that is finger, the width of this angul. The question will come to your mind that everybody, like a child, a strong man, and also a small heighted person, it will all differ. But they took this and they made it standardized. So definition comes from where? Digit it is angul, cubit is this one, and person's height is purush. So this is what they defined. The way you said foot, pound, second. Foot is what? When you walk, the distance between two steps is 1 foot. So that was British system. But we found this. And now you see this scale which is found in different places. Be it Harappa bronze scale, you see the graduations. And these graduations are serving two purposes. It is a kind of nakshatra scale. It is also measuring the astronomical observations are also taken, and also the distance, linear measurements are also taken. So you can see here this V kind of shape is there, and if you find the distance between two graduations, that is all same, and be it Lothal side or Kalibangan side, you will find that the length or the distance between these two is about 1.77 centimeter, something like. So this was uniformly, and it is also found elsewhere outside India at that point of time. So Lothal ivory scale, Kalibangan terracotta scale, the scales are there which you can see on this, and the accuracy is 0.01 angul. So metrology, the concept was present there, and people practiced the precision in measurement in length, weight, as well as time. And these are all like, and then you'll find a text in which barley, the grains, they were also considered as 1 unit. In some cases, linseed was also taken as 1 unit, and then they made it standard. So this is precise scale in which finally we found it about 1.6764. So angula is precisely this much value, and we have gone through a systematic study. The other numbers are discarded, and this number comes out to be 1.6764. Whatever be the site, the Mohenjo-daro, Sumerian, or Lothal, Kalibangan, or Harappa, these scales are, and they were engraved on, they were found as engraved on the walls of temples, ancient temples, for example in Kanchipuram in South India. So not only the way, if you find it out in your textbook, somebody will say कि वो पेरिस में एक प्लेटिनम इरिडियम का एक धातु रखा है, इतना लंबा है, उसको 1 मीटर कहते हैं. That is what the definition you had in early days. Likewise, where to preserve those standards? So in temple, that graduation was marked so that whosoever wants to make it ratified, verified, you can go there. And then that is what made universal, uniform across the civilization. And these are other studies in which you can find the digit or the palm or the foot or cubit or dhanush, which was also used one such unit. That is all available, and I'll keep my slides here. It is not that I have done the exhaustive study and it is all complete. It requires further developments in terms of finding out the original sources and corroborate the evidences in a nice manner. So another quantification was done with the help of the different measurements were there: speck of dust, tip of hair, louse, grain of barley. And if you go one by one, angula is one finger width, vitasti is like this, danda, kosh, and yojana, and finally, how many yojana comprises of Earth circumference. So these are all studied by many people, and I have taken from Francis, who studied it in 1998, and he found some closeness with the values adopted during the British colonial period. So again, this table is from different other sources like Buddhayan Sulba Sutra, then Kautilya's Arthashastra, Aryabhatiya, Varahamihir's Brihat Sangita, and Lilavati of Bhaskar. You see, all these sizes are having a measurement value which is given there. And in Chanakya's Arthashastra, you will find many other ways of representing the measurement values. Time does not permit, neither it requires to go into those details. The idea of this particular talk is to appraise you that it was not by some kind of ad hoc measurement, it was all done systematically to come at a precision of measurement. So that is what the purpose is. Today in the morning, it was also referred that why we needed 10 to the power something, जो कोटि का concept है, ऐसा क्यों था? और आप देखिए कि 10 to the power 53. In some of the texts, they also showed that it is more than that. That means we used to measure larger distances also. So, and also in terms of the time which are there, that is concept of yuga and many other concepts were there which we need to understand from the perspective of our ancient people. For example, Lok and Visva, they defined that there is 7 lokas, and every loka has got different units. The way, like today also, if we have to talk about galactic measurements, we don't use meter, we use parsec, we use some other unit. For example, in different lokas, the measurement units were also different. So 7 lokas, 7 Vishwas, and this is what is given in Rig Veda, that we had 7 yojanas and 7 yugas, and these 7 yojana and 7 yugas were used in different contexts. For example, for astronomy, the yojana was something different, and in case of human use, which is given in Lilavati, the yojana was something different. So we have to understand, we should be not judgmental that all the yojanas were of different. They were used for a purpose, for a different loka, and then that was quantified that way. So last time when I was objected by Ram Subramaniam Sahab that yojana is having different values in different texts, is because we are having some missing link and we have to understand the different connotations under which these yojana is used. So you can see in Vishnu Puran, the 7 lokas are defined in a different manner, and higher lokas, Bhu, Bhuvar, Swar, Mahar, Jana, Tapa, Satya, and every lok, the yojana is defined differently. Bhu yojana, Bhuvar yojana, Swar yojana. So I have taken some of the examples in higher worlds, how they are taken, how the values are actually chosen. So in case of higher lokas, the Jana Yojana, that is Nar Yojana, which is called, how they are used, I'll give you those examples. And the lower yoga, just now you have heard about this Ayurveda, and in that case also, this smaller world, microscopic, somebody today in the morning referred, सब पिंड की बात करते हैं, पिंड ब्रह्मांड में हो चाहे वो हो, सब एक आप उसको एक साथ में कोरिलेट करते हैं. यहाँ भी आप देखिए कि the definitions which are taken for a cell in the lower world, that is also defined in terms of 10 to the minus 15 meter, 10 to the minus 10 meters. So that kind of thing is also found for the जिसको हम लोग तल पाताल अतल की बात करते हुए 7 लोक नीचे और 7 लोक ऊपर की तरफ बात करते हैं, and then all those measurements are found in those cases. For example, for cell, for atom, jiva, kundalini, jagat, deva. So see, kundalini, there was again a science of meditation. एक टेक्स्ट है जिसको हम लोग कहते हैं विज्ञान भैरव तंत्र. Vigyan Bhairav Tantra is 112 sutras in which there is a samvad between Shiva and Parvati. Parvati asks कि हमको क्या करें जिससे कि अपने को कहीं पर एकाग्र चित्त कर सके. All the 112 sutras are similar. किसी एक को आप प्रैक्टिस करिए. Why it is called Vigyan Bhairav Tantra? Because your body is an experimental lab, and the method which is being prescribed is scientific. Scientific in what sense? And that was simplified later by Gautam Buddha, which you call mindfulness, which you call vipassana. All those techniques were perfected by simplifying those sutras which are there in Vigyan Bhairav Tantra. So this Kundalini has also got some meaning which we cannot find otherwise anatomically, but that is there, which we have found in many texts. The yogis, they try to, जैसे कुंडलिनी जागरण की बात करते हैं, वो वहाँ पर आपको मिलता है. तो ये आपके तमाम लोक हैं, 7 लोक ऊपर, 7 लोक नीचे, और इन सभी लोकों में जो डेफिनेशन ऑफ मेजरमेंट है वो अलग अलग प्रकार से है. एंड द योजना विच आई एम टॉकिंग अबाउट, विच हैज़ गॉट सम कंफ्यूजन इन टर्म्स ऑफ इट्स लेंथ, हाउ मच माइल्स वन योजना हैज़. सो I am still working in this direction, and I have found many texts. So in coming days, I'll definitely try to resolve those issues. तो अभी आपका ध्यान इतना तक ही सीमित करते हैं, and I'll come to the next part, which is the second type of measurement, which is, these are all different kind of yojana in which the definition is given differently. The other important thing is the Harappan settlement, which is found to be the advanced urban planning, town planning. All these ratios which are found in those houses are in perfect. For example, granary, they are in the ratio of 4:3. How many bricks are in the length direction, how many bricks are in the width. So that is also nicely studied, and that study is all found. The building in HR area, the college, block 6, pillar hall, these have different dimensions, and if you find the error is very minimal. And this is what the town planning is, in which different rooms, different facilities have got different ratios, and that is what Dhulavira studied by Michael Danino. This is all published work, is secondary source by others. So, and this is what the planning which we have, and the bricks which were used, measured in angula, they were also found in terms of their dimension, length versus height, or the LWD. So that is all documented. It is not that all the bricks are different size. They are all made of same sancha, jo dai hai, that is all same. I was talking about this Purush Shukt Vayu Mandala, and this has also got an important connotation. you see how well they used to prepare the Havan Vedi. If you have to understand the concept of weight as well as volume, different size की हवन वेदी और उसमें कितनी आहुतियाँ आप डालेंगे, that was all calculated. And ये जो डिफरेंट पर्पजेस थे कि किस प्रकार का आपका शेप होगा कुंड का, हवन कुंड का, और उसका डायमेंशन क्या होगा, उसमें कितना उसका वॉल्यूम होगा और उसमें कितनी आहुतियाँ आप डालेंगे. ये भी मुझे लगता है कि इस पर वैदिक मैथमेटिक्स पर बात होगी. एंड दैट इज़ ऑल नाइसली कवर्ड इफ़ यू टॉक अबाउट one aspect, that is measurement. Coming to time, we have again, this is again a much talked about, debated topic. How निमिष पलक झपकने को कैसे आप लेंगे, एक कमल का पत्ता लेकर के उसके ऊपर आप पियर्स करते हैं नीडल से, what is the time taken. But if you go into the text, you will find there is a statistics. 100 times, 1000 times you do and then you take average. So that is what they use to determine what is the time unit for measuring. And these are all defined in different context. एक दूसरा concept था अक्षर. आप सभी जानते हैं कि माहेश्वर सूत्र अ ई उ अ ड़ री री कर जो शंकर के तांडव नृत्य के बाद जब उन्होंने डमरू बजाया तो वो जो 14 माहेश्वर सूत्र हैं उन्हीं से संस्कृत का जन्म हुआ. अक्षर का जो कॉन्सेप्ट है, जो आप कोई उच्चारण करते हैं, उच्चारण करने में कितना समय लगता है उसको क्वांटिफाई कर सकते हैं. दिस इज़ वन सच स्टडी इन विच ऋग्वेद की डिफरेंट सूक्त, इनको अगर आप उच्चारण करें उसमें कुल कितने अक्षर हैं और उन अक्षरों को उच्चारण करने में कितना समय लगता है, टाइम इन सेकेंड्स. इफ़ यू प्लॉट इट, यू विल फाइंड टू डिफरेंट परंपराज. सदर्न इंडियन context and then in context you will find the number of akshara when they are pronounced. That is another measure where you take akshar as unit of measurement of time. And we all know while having this Janagalman, the Rashtragan, you take 52 seconds to get it completed. So that way this kind of concept was also there in which akshar was quantified. So Akshar was a basic unit, and I have taken this work from R.N. Iyengar. He has studied in detail, and whole range of such kind of measurement units are there if you talk about. And if you look at Bhagavad Gita, chapter 8, verse 17, you'll also find that what is the definition of yug, how different ages are there, and how can we Shri Krishna, he explains that how this yuga comes one by one, जहाँ पर आप पा सकते हैं कि कैसे define किया गया. ये अलग से एक दूसरा manifestation है, which I wanted to correlate with the modern concept that how this geological period is divided, and the modern concept is that glacial periods, after that the civilization comes for 10,000, again it goes into glacial period, right, is because of precession of equinoxes. So whole range of such kind of the domain of this time was divided into different kalp, महायुग, युग, ब्रह्मा का युग, ये सब चीज़ें पहले से ही उस तरह से लोगों ने कहा. तो my point is that when you are going to study, you have to take the way they used to define, they used to have their definitions instead of projecting our idea into them. Then you will be misled. Otherwise, everything they try to put in a more logical and systematic manner, which is very much, I will not say closer, but in some sense you can say that this is much advanced in terms of their definition. So again the time has nimish, kast, kala, muhurt, ahoratra. Or why we require this? Because I talked about astronomy, I talked about this Phalit Jyotish, calculating muhurt is important, and that is all done based on mathematics, which was known to them very dearly. So I will stop here. I will not go into those details. The point was that these are all documented. Only thing is that there are many missing links which need to be understood, and also instead of looking at the secondary sources, we have to interpret the text which is there in secondary sources with the original ancient texts. And a lot of things can be done to understand, to re-establish the original context, original idea into the context. Thank you very much.
Thank you, Professor, for your enlightening talk and for sharing your invaluable insights on measurements. Now I request our Chairman, Sir, Dr. S.C. Wirtz and Professor Deshmukh, Sir, to please present a token of appreciation to Sir. Please welcome on stage. Sir, please. Sir. Thank you, sir. Next, we are honored to welcome Professor M.S. Sriram, former professor at the University of Madras. Professor M.S. Sriram did his PhD in physics in 1978 from IIT Kanpur. He worked in the University of Allahabad before joining the University of Madras, from where he retired as a professor and head in 2011. Currently, he is with Professor K.V. Sarma Research Foundation, Chennai. Apart from his research in physics, he has been working in the field of Indian astronomy and mathematics, and also 3 important texts of the Kerala School of Astronomy and Mathematics, namely Yukti Bhasha, Tantra Sangra, and Karan Paddhati, with co-authors. Recently, he has completed a book on Siddhanta Shiromani, the major work of Bhaskaracharya, and is working on 2 Kerala texts on astronomy with co-authors. He was elected as a Fellow of the Indian National Science Academy recently for his contributions in the area of Indian astronomy and mathematics. With an illustrious career in academia, Professor Sriram has made significant contributions to his field and has been a guiding force for many students and researchers throughout his tenure. I welcome Professor Sriram to the stage for delivering his talk on nature of the Indian astronomical tradition. Thank you.
Thank you.
So please.
I thank the authorities in this institute for the excellent hospitality, senior and junior workers, and I also thank Professor Deshmukh, who was very keen on having some of us. In fact, about nearly 30 years back, when we did some work on the revised planetary model by Nilakanta Somayaji, which was just mentioned by Ram Subramaniam, MD Srinivas, and we told Deshmukh about it, and he was kind enough to include it in the syllabus, for the classical mechanics course for the undergraduate students. So he was kind enough to introduce them to the topic, though we are not that well known. And normally if you make any claim at those times, at least you are highly suspicious. People, especially in the scientific community, are extremely suspicious about any claims about very important things being done in the country in the past. Okay, so at that time he was kind enough to include that. Okay, so my talk is on the nature of the Indian astronomical tradition. So Bharatiya and modern systems, the nature of discussion on the knowledge systems, including comparison with the prevalent modern dominant systems, would vary depending upon the nature of the discipline considered. In disciplines like agriculture, water management, medicine, or architecture, the differences between the Indian and modern methods are glaring. For instance, there is a clear-cut distinction between the characterization of a disease and its treatment in modern medicine and Ayurveda. In the former, the diagnosis and the treatment are at the molecular biological level, whereas in the later, that is in the modern system, it is the molecular biological level, whereas in the Ayurveda, they are based on the very different concept of balance of three doshas in the body. See, Vata, Pitta, Kapha, you have heard about it. In more theoretical disciplines like astronomy and mathematics, very clear-cut distinction in the sense of this method in total contrast to that method may not be there. But there are distinctions, there are distinctive features. So for instance, this is the diagram of a celestial sphere. You see what you see on the sky, sky and in the night, when you look at it, it will look like anytime it will look like a hemisphere, right? And in the night you can see the objects clearly apart from sun and all that. So this hemisphere is called a celestial sphere, and in India it's called Khagola in Sanskrit text. The uppermost point is zenith. Now it's called zenith. We call it Khamadya. The north celestial pole was called Dhruva in Indian text. Then the horizon is Kshitij. Then you have this equator, celestial equator, which is parallel to our equator, you see. So that is at any this celestial equator, that will be inclined to this vertical by the latitude of the place. So that's called celestial equator nowadays. It was called Ghatika Mandala or Ghatika Vrutta or Vishuvat Vrutta. Then ecliptic, that is the path in which the sun, moon and all that move, planets, they move close to the ecliptic. Sun moves on the ecliptic by definition. That's called Kranti Mandala. The declination, how much is the sun varying from equator, okay, how much is this, that is called Kranti. So like that, and that what is known as 6 o'clock circle. So that is, any body will rise in the eastern portion of the sky, any celestial body, like sun, moon, planets, stars, everything. It will go up, in a circle and then come down, okay. So that is called a diurnal circle. And that is called in India Ahoratra Vrutta. And when it comes, you see, when it goes up, it reaches the middle circle, you see that vertical circle. So that is called meridian. Now, it used to be called Yamyottara Vrutta or Dakshinottara Vrutta in Indian texts. So from there, you see, when it comes down, how much time? You see, time can be measured in degrees or hours or Ghatikas, okay? Degrees means 360 degrees is equivalent to 24 hours or equivalent to 60 Ghatikas. So, when it comes to this circle, which I have written as 6 o'clock circle, that is called Unmandala. It would have covered 90 degrees. So, from the meridian to that circle, so that is 90 degrees or 6 hours. So, that is how it, so concepts are similar. So the objects and variables of interest in Indian text and the initial phase of modern spherical astronomy before celestial mechanics are the same. Okay. Of course, after this 18th, 17th century, things are different. Okay. They talk about celestial mechanics. But before that, what was there, and much of it is of, Indians were already using it, those kinds of concepts. I will come to that in a little more detail. So the terminology in Sanskrit regarding celestial objects is mostly directly mappable to modern terminology. Similar things are calculated, but in different ways. For instance, the shadow of a gnomon, okay? So one vertical stick. So you, shadow of this thing, when sun's rays are coming, the shadow of the stick is observed. From the length of the shadow, one can find out the time, you see. So that is given as a very important topic in Indian astronomy texts. It's called a gnomon or vertical objects. So methods to calculate are different in details, quite a bit, at least especially in the olden Indian texts. The method to actually calculate that, and it is directly related to time, is different from the modern this thing. But the overall result are the same, okay? Because both the calculations, if both of them are correct, then, they should be the same. And similarly, calculations related to eclipse, beginning, middle, end, and all that. So there are similarities. I mean, similar things are, astronomy is astronomy, okay? So similar things are talked about. But, however, Indian astronomy has its own distinctive characteristic, that is a sutra format. So quantitative astronomy as a scientific discipline in India can be traced to Vedanga Jyotisha around 1250 BC. This is in the sutra format, or it's algorithmic in nature, okay? So you get short rules for various calculation of various things. Okay, Vedanga Jyotisha, if you remember, was mentioned by Professor Srinivas also. So it is, you can say, the first mathematical astronomy text. Mathematical means it is not, I will come to that. It is a simple mathematics at that time, what can be called arithmetical astronomy. So here you have a 5 yuga. Avinash Chandra Pandey was just now telling that you have got a Mahayuga of 43 lakh 20,000 years and 1,000 such is Kalpa and all that. But in beginning, even before Vedanga Jyotisha, they used to have a concept of 5-year yuga, short yuga, okay? So if you have a 5-year yuga, 1830 days, in that there are 1830 days, so which consists of 60 solar months, 67 sidereal months, or 62 lunar months. So we have a calendar. Earlier also it was there, calendar concept was there in Vedic text and all that. But here says mathematical kind of a calendar, which is precise rules are there. So we have 60 solar months and 62 lunar months in 5 years. So 2 additional lunar months. So it's called intercalary months or Adhika Masa. Okay? 2 Adhika Masas in 5 years. And concept of a Tithi, 1/30th of a lunar month, is introduced. Okay? So these are the concepts which you are following even now in India. Tithi was perhaps introduced first here. You see? In fact, in the poster of the brochure of the conference, we said Ekadashi, Dwadashi, and Trayodashi, okay, of Ashvina, Shukla Paksha, it is written, okay. So that's got a definite meaning. So Tithi. So Tithi concept was there. That tells you about what is the angular separation between sun and moon as observed from the earth, okay. So the Tithi concept was there. So that is, and Adhika Masa, you see, sometimes you have 13 lunar months instead of 12 lunar months in a year. You see, that is because if 12 lunar month is equal to 354 days, and 1 year is, that 365.25 roughly, okay. So to bridge the gap, so 11 days gap is there, so you have to introduce an additional lunar month, okay. So that is the concept of Adhika, which is still followed in India, you see, from the time. In fact, it dates back even before Vedanga Jyotisha. So this Adhika Masa is there. So those concepts are used. Okay. So now, the short algorithms are there for finding positions of sun, moon, tithi, nakshatra. Importantly, for finding the duration of daytime over the course of the year. What is the duration of daytime? That is sunrise to sunset. That is the daytime. Okay. What is it? That varies. You see. See, in Chennai, it doesn't vary too much. It is near equator. For in Delhi, it will be quite a bit. You see, the first time I came to, Kanpur in north, you see, from Bangalore, and I was somewhat shocked that, in the winter, it is sun is setting at 5 o'clock. You see, so early in the winter. So that is because it varies over the year. That depends upon the sun thing and all that. And I'll come to that. In the Indians, for the first to give a precise formula for that, how the variation happens. Okay. So they are assumed to be uniform. Okay. Here the sun and moon are all moving uniformly in the stellar background. Okay. but are actually non-uniform in reality. So the computed values would be approximate to that extent. But after each yuga, the sun and moon come back together at the same position in the stellar background. That is the assumption. Okay? So like the cycle of seasons, but longer. So again, this is approximate, but the important thing is the concept of some kind of a cyclic time, which is still followed in India, right? I mean, this kind of a thing, that whole concept of time is cyclic. Earlier it was a short yuga of 5 years, then it is a Mahayuga of 43,20,000 years, and so on. Okay. So these central concepts are not changing. So because it is approximate, probably corrections were made. This is a simple scheme and simple mathematically to compute. So some scholars feel that, they made it simple, though they may have known that it is somewhat approximate, so that some corrections were made, in these things. The important thing is the sutra format. You see, that is the Indian way of doing things. So people had mentioned it. You see, you give the rules, you see, and then you explain the rules. So like in grammar, you have the Panini's Ashtadhyayi. There is a set of rules for generating the proper sentences in Sanskrit. Or you have the Chandas Sutra, the rules for, this prosody kind of a thing. Okay? So this kind of rules is there across the disciplines. And that is the sutra format. And in Vedanga, which is the first text in astronomy, mathematical astronomy text, which was followed later by other texts. Okay. So, and it is in verses. The Vedanga Jyotisha is only about 40 verses, so there are two versions, but 40 verses, so it is easy for persons to remember. Okay, that is the thing. So the algorithmic nature continues in the later Siddhantic texts, like Bharatiya, which was in 499 CE, it is composed in that. Brahmasputa Siddhanta, Siddhanta Shiromani, Tantra Sangraha, to name only a few. You see, there are many more Siddhanta texts, in which we now have a Mahayuga 43,20,000 years. After which, sun, moon and all planets return to the same position in the stellar background. Or after a kalpa of 1,000 Mahayugas, the other variables associated with planets like nodes and apogees also return to the same position. So we have the concept of cyclic time linked with Indian cosmological concepts. And in this Mahayugas, number of revolution of sun is 43,20,000. That is the definition of year itself is that, that 43 lakh, this number of years means number of revolutions of the sun in the stellar background. Moon is that number, Mars, Jupiter and other. So one can find average positions of the stars from these planets. From the sun and moon also were considered as planets. So it is basically a geocentric kind of a framework. So planets, sun, moon and planets are all moving, stars are all moving around the earth kind of a thing. So that is the conception. So one can find the average positions of the planets from these numbers. Okay. Now schemes should be devised to get non-uniform motions of planets. So that is why there the trigonometry is needed. So that is the thing. Now the Indian Jya is so this is the thing. So the circle is there. Okay. So then this OBD, that is the straight line, and then OA is the straight line. The angle between them, what we call angle is this theta now, you see. And suppose the arc is AD, okay, so that is arc theta. Then drop a perpendicular from A to B. So that is the Jya, Indian Jya, okay. Jya is AB, is r sin theta. So in Indian trigonometry, this Jya is a length, whereas normally, in modern trigonometry, Jya is the ratio, is right, opposite side by hypotenuse. But it is same as modern sine and cosine except for r, you see, except for r, because of this length, this thing. So normally it is circumference of a circle is taken to be 21,600 units. So angle of 1 minute or 1/60th of a degree corresponds to arc of 1 unit. So r comes out to be around 3438. It's called Trijya. Whereas the Greeks did with what is known as chords, okay. So here, you see, there is a arc AC, okay, connecting it to the straight line, that's called chord AC, okay. So that AC is the chord corresponding to the arc AC, and that is chord of 2 theta here essentially. So they are related, but there is no right triangle in the definition of the chord, no right angle triangle. So there is no cosine and all that. And soon it will be realized that Indian sign is far more convenient for writing formulae and computations as we see. You see. So though they are, Indians might have been inspired by the chord, concept of chord, but it is an entirely different trigonometry. So that modern trigonometry is basically Indian invention, we can say that. Yeah. So just to give you an example how the sine function comes, I don't want to be technical, but I will say that non-uniform motion. You see, if everything was uniform, then there wouldn't have been any, physics. No, because non-uniform motion is the beginning of this classical mechanics and all that, because only then the concept of acceleration, force, etc. comes. Okay. So now understand non-uniform motion is a very important thing. So what they did was, that they had a concept of what is known as the epicycle, which is an artifact to explain non-uniform motion. Okay. So suppose there is an object, a celestial object. So it is moving, to begin with you say that it is moving uniformly. Okay. So that is P0. That's called a Madhyama Graha or mean planet, moving on a big circle of radius r. Okay. There is a Mandocha whose direction is specified, okay, and the actual planet is in a small circle called epicycle of radius r, such that this is P0 P is parallel to some direction, okay, basically some big axis of the ellipse. We know that the planets move around ellipses nowadays, okay. So it is something like that, okay. It eventually turned out to be that. So I don't want to go into too much of these details. So the mean longitude is this, gamma OP0, and longitude of Mandocha is theta m, okay, and minus delta theta, there is the correction, this is the correction, the true planet is this gamma OP, and this is called Mandasputa. It is theta 0 minus delta theta, where delta theta is this, okay. So what you don't bother about epicycle model too much, so what I wanted to say is how the signs come. It is inevitable. To explain the non-uniform motion, you should have the sine inverse and all that. That's how it will come. Okay. So this is the kind of formula. So epicycle model probably originated in Greek astronomy, but no such formula is there. There is no formula. I will come to that. Indians only had formulae. In Europe and all that, it came much later, and they had to use tedious use of tables to find delta theta. Okay. So it is epicycle model, etc. is there in Ptolemy's Almagest and all that. So for that, to find out the non-uniform correction, to get the correct position, you have to go from arc to chord and then back to chord to some other chord related to that, to arc and so on. See, it's very tedious procedure. Whereas in India, straight away you have got this. This is a formula, you see. Inverse. So this is the formula. That is the important distinction. Okay. Yeah. See, for instance, as I told you, duration of daytime. When you want to find out the duration of daytime, okay, so then, sorry. Yeah. So the sun's diurnal path is there. At any given day, when its declination is delta, that is when it is removed from the equator. So then one can show that its latitude to the place is phi, the declination is delta. You see the sun from the meridian to this, it is coming 6 o'clock circle, that is 90 degrees or 6 hours, but it has to travel some more to set. Okay, 6 hours plus something, and then the same 6 hours plus something the other side, you see. So the meridian transit 90 degrees plus delta alpha, and sunrise to sunset is twice of this, okay. and delta of alpha is this, sine inverse of this, you see. So this is given basically in Aryabhatiya, okay. Of course, he doesn't explain it fully. As mentioned, it is very cryptic, okay. It's very, very concise book, and Bhaskara one only had to explain it and all that for it to be intelligible to everybody. So this formula is there, but more detail you get Brahmasputa Siddhanta, Brahmagupta and all that, all these things are explained. So this is the duration of daytime, you see. And of course they didn't talk of degrees, they said Ghatikas. So finally, so the duration normally it is 30 Ghatikas when it is, on March 21st or September 23rd, that is when it is the equator, plus or minus this, you see, 1/6 delta alpha. This is the formula. So the very formula is there, you see. Of course, it is written in terms of verses, you see, and they will express it differently. So what they will say is, sin phi. So they will not say sin phi. They will say that, akshajya. Akshajya is multiplied by krantijya. Krantijya is divided by lambajya, and that was further divided by jujya. You are laughing. And then you take the chapa of that. But it is essentially equivalent to a formula. Okay. Yeah. So importance of Indian Jya was recognized, you see, by at least the historians of mathematics of yesteryears. So one Sarton, he says, handling of science is much simpler than that of chords. Our trigonometric formulae, both plane and spherical, are relatively simple and elegant because of their symmetry. Similar formulas based on chords would be more complicated and less elegant. Nobody had the courage, however, to deduce them formulas based on chords, because the Indian science drove the Greek chords, drove them away forever. You see, this is, I got it from a thesis of one famous historian of mathematics called Ashrigupta. And of course, Ashrigupta adds, just as, the Indian number system drove away all the other systems, you see. So, this is the important. And one Boyer, he says, thus was born apparently in India the predecessor of the modern trigonometric function known as the sine of an angle, and the introduction of the sine function represents the chief contribution of Siddhantas to the history of mathematics. And again one Bond, he says it was by the use of Indian sine that the Arabs were enabled to build on the Greek formulation of auxiliary trigonometry of the chords, the complete and independent trigonometry of the sine. So the most important thing is sine is considered as a function, okay? So at any given time you find out the mean longitude, you get the correct true longitude using the sine function. So that you are written as a formula, you see. So that is only possible because of, the Indian approach, yeah. Now, it was because the Indians expressed the true longitude of a planet in terms of sine function that they could think of finding an expression for the rate of motion of a planet also as a function, which is the derivative of the longitude, okay. So from the earlier expression for this, we had this, the Mandasputa was this, and approximately theta 0 minus r0 by r sine m, okay. Using the concept of a derivative now, okay, we can immediately, what is the problem in deriving the derivative of sine? Sine is cosine, okay. So you get this. In Mahasiddhanta of Aryabhata 2, he is called Sputagati, the true rate of motion. Sputagati is equal to Madhyagati minus Koti Phala of Mandakendra into Mandakendra Gati by Trijya. So he gives the formula. And even before that, Manjulacharya had given that. Okay. So because they could write it in terms of the sine function, they could find out the rate of motion. But if you just always stick to geometry, okay, and write geometrical model for these things, you will not even think of writing an expression for the rate of motion. You will think that you have to do more and more complicated geometry and all that, you see. And that's what they did. And that is what even Newton Baba did. Newton, he is supposed to be the discoverer of calculus. I heard some European scholar talking about Newton. Okay, this is in 17th century. He said, I have not read Newton's Principia, not even translation. So he has said that there is no formula in Newton's Principia. And all these things, all these treatments are completely geometrical. And one more thing, we think that, Newton was a very great person. Of course, he was a great person, who changed the course of this thing. But he had a deep amount of admiration for the old Greek tradition, okay? So the Greek, we should learn from them, He had deep admiration for and he has used all these old Greek methods of geometry to deriving various things, complicated things in mechanics. So that is the thing, But here we have a straight away this kind of a formula. Okay. Later, Bhaskaracharya, of course, he explains things more in detail. So he discusses the instantaneous rate of motion in Siddhanta Shiromani. He says, the true daily dinantara spashta khagantaram syad gati sputa tat samyantarale koti phalagni etc. Tijyoduta karki mrugandikendra taya yutona graha madhya bhuktis tatkaliki manda parisputa syat. Okay. So he said the true daily motion of a planet is the difference between the true planets and successive days. Okay. So how the position is changing. So you see it sunrise at one day and next day kind of a thing, So you will get a rate of motion, okay? And you take it as some kind of, as if it is uniform throughout. But he's not like that. He says that the Kotiphala is multiplied by the rate of motion of Manda and Amali and then added or subtracted. That is because they used to take only the magnitude of cos. So you know that the cos is, in the first quadrant and fourth quadrant it is positive and things like that. So that has to be taken into account, So that's why he said, yuta una, okay, you are added or subtracted. That is only a small technical matter. So he is saying precisely this, he is giving this in a shloka form. And there is detailed explanation of this in his commentary. And note the usage of instantaneous rate of motion, tatkaliki. Okay, so we credit instantaneous velocity to Newton, okay, and that is considered as one of the major advances. But instantaneous rate of motion is already there. Bhaskara discusses it. In fact, he discusses it more in his Siddhanta Shiromani, more than 5 centuries before Newton. Okay, so the above method for finding the instantaneous rate of motion is satisfactory for Sun and Moon. For planets, it is more difficult, okay. So we need not go into the technical details. He discusses the problem, and there were some ways of doing it. People were doing it even before Bhaskara, but he says they were all, they were not getting correctly. So Bhaskara notices the flaw. He says that a new approach is required. And with some ingenious geometrical reasoning combined with trigonometry and calculus ideas, he had the calculus ideas, he arrives at the true velocity of a planet. So this is exact in the Indian framework for planetary motions, okay? So that is not a retrograde motion and all that, sometimes that planets go forward or backward and all that. It's not an easy thing, okay? So that he does by using a new approach. I can't do this thing, But he gets, the calculus ideas are there and kind of a new approach is there. All these are not given due credit in the international history of science narratives of the correct times, of the current times, okay? So they are, earlier we thought that there was some admiration and all, but now somehow they are not, they don't even pay attention to what was there, what many people have said, in 1930s or 50s or 70s or what some of us are this thing, they don't pay attention, that is all. Because they are obsessed, Greek ka ho gaya, then afterwards Arabs, okay? They are completely up, and before Greeks, Babylonians, They are only interested in that, So it is our duty to build a narrative, Indian narrative kind of a thing, it is like, if Indian music, so it may not be appreciated by Westerners, so what? They don't care, whether you appreciate, the Western classical music, right? Do they care? Of course, they may be nice and they appreciate you if you appreciate that. But we don't have to bother, and you get greatly elated, if some, they say make some appreciative comments and, become dejected if they make some negative comments. See, one has to build up one own narrative. I mean, in any Indian discipline. So that is I think that is, I am sure most of the scholars here will certainly agree. Okay. Now, this is only the algorithm. Was it just algorithm, rule and all that, or more? Okay. So, the practitioners of astronomy were supposed to have the algorithms at their fingertips. Okay. So, Bharatiya, it is, those days it would have been very easy to mug up. Only 129 one verses. And that is only about 240 and odd short lines. Right. That's all. You see. So, it would have been easy to memorize. And even Bhaskara Siddhanta Shiromani, it is about 460 verses. So it may not be very difficult, you see. A few months one can, memorize all the algorithms. But that is not the only this thing. One has to go beyond that. So they have to know the algorithms, that they have the knowledge at their fingertips. And Karana texts actually focus completely on computations. Simplified as much as possible, suitable for day-to-day applications. But a great astronomer like Bhaskaracharya emphasizes the need for practitioners to understand the rationales of the procedures. He himself derives or gives upapattis for all the algorithms of his Siddhanta Shiromani in his auto commentary, Vasana Bhashya. Okay? So the explanation have to be understood, you see, not just mug up and cram. Okay? So one has to understand all the rationale and all the detailed reasoning. So that's what And he says in one of the places in Siddhanta Shiromani, says, Janan Jataka Samhitaha Saganita Skandeka Desha Api Jyotish Shastra Vichara Sara Chotara Prashneshva Kinchit Karaha. Of course, it's beautiful poetry. I may not be saying it very well. Yaha Siddhantam Ananta Yukta Vitanam No Veti Mitto Yatha Raja Chitramayo Thava Sugatitaha Kashtasya Kantiravaha Garjat Kunjara Varjita Drupachamura api urjitashvadikaihi udyanam chutachita vukshamatava pato vihinam sarha yoshit proshita nutana priyatama yadvanna bhatyachakaihi jyotish shastramidam tataiva vibudaha siddhantahinam jaguhu. So what he is saying is, by mastering only one branch of astral sciences, namely Jataka is mainly Phalita Jyotisha, astrology, Samhita or omens, you see, the Bruhat Samhita is full of omens, this thing. Or Ganita, that is the mathematical astronomy. One cannot answer so many intricate problems pertaining to it. Such a person who does not know the theoretical part of the astral science, which abounds in innumerable reasonings, is one like a king depicted in a drawing. You see, a king in a drawing is just that, it is drawing, okay? Or a lion which is made out of wood. Intelligent people say that the science of Jyotisha without the Siddhanta is like a king's army without roaring elephants, though excelling in horses, etc. You see, you may move fast with horses. It is like a garden without mango trees, or like a lake without water. And again, like a lady parted with her newly married lover, you see. So that they always make these things quite interesting. The sutra format, or coming to the end of my talk, the sutra format or algorithmic nature of Indian astronomy is well known. Okay. Okay. In fact, a very word algorithm is, it derived from Al-Khwarizmi, the Central Asian astronomer, right? Islamic astronomer. But actually, Al-Khwarizmi studied many Indian texts. You see, it had been introduced even earlier. He must have been in, I think, the 9th, 10th century. Before that itself, Indian mathematics and astronomy had reached the Islamic Arab areas. And he wrote a book on the Hindu method of reckoning. Okay, Hindu method of calculations and all that, you see. So he was inspired by that. And so, though algorithm is, derived from Al-Khwarizmi, it has deep-rooted Indian connection, because Al-Khwarizmi himself was deeply influenced by the Indian method. Like most Islamic Arab mathematician astronomers before 8th, 9th century. So, commentaries are very important, and they describe the algorithms in detail, and more importantly give the upapattis or rationales or derivations. They may not be exactly like the Euclidean method of, to have a set of assumptions, axioms, and then derive all the rules. It is not like that. Any reasonable kind of explanation, you see, which is completely logical and with demonstration and suitable diagrams and all that, which will convince a person, that is called an upapatti. So, a later work, Ganita Yukti Bhasha of Deva is entirely devoted to rationals, you see. It is a book which is related to rationals, and that is where, we learn, how exactly the Kerala astronomers, mathematicians, you see, they understood the sine series, cosine series, infinite series for pi and all that, you see. So that how exactly they understood it, how they derived it, they are all in this. And it also talks about planetary models and all that in detail. All rationales only, you see, proofs. And we have sine as a function. So you have formulae for various variables, and they are far ahead of times. See, as I told, there are no formulae in Indian, other civilizations. You see. Here you got a ready-made formulae kind of a thing, because sine is a function, and from that, you write the positions of planets in terms of the sine function and other variables. You write the various, how to find out the shadow corresponding to a given time. You write a formula for that. For eclipse, you see, when does the eclipse actually occur? You see, you give a procedure. And the middle of the eclipse, and when does it start, when does it end? All these are given in terms of formula. Okay. So they are far ahead of times, and they could think of calculus ideas in finding rates of motion and all that, because of this, writing in terms of sine as a function and other things as a function, and they could think of instantaneous velocity. There is continuity as well as evolution. Bhaskaracharya consolidates the work till 12th century and takes it forward. So Bhaskara's Siddhanta Shiromani was in 1150, 1150 CE. And Kerala school of astronomers, Nilakanta Somayaji, etc., they 14th to 17th century, and even elsewhere, take the tradition even further. In fact, it is quite a living tradition, even, let us say, till 19th century. There is one famous Chandrasekhara Samanta, Oriya astronomer, or Patani Samanta. There is a Patani Samanta planetarium in Bhubaneswar. So he might be, in one way, he can be considered the last great Indian astronomer in the Siddhantic traditions. He devised some experiments, he devised some instruments to do various kinds of, measurements on planets and moon and sun and all that, you see. So he worked in the Siddhantic tradition, though probably he knew about the modern European invasions. It's already, he wrote his Siddhanta Darpana around 1860 or so. But he wrote it completely within the Indian framework. And so, and some other places also, they take the tradition even further. One more important aspect is that there are, works in regional languages. For instance, many of the Kerala works are in Malayalam. Apart from that, there are many other, many commentaries and, texts, mainly calculation manuals in later in Hindi, then Kannada, then Telugu and all that, which are, come even from 16th century or so, you see. So this is, that is the kind of propaganda we have, that they are all confined to a few people, in India. They are all confined to this, they wouldn't let us these things, It is completely far removed from ordinary people. That is not complete, it is completely wrong. Because there are various gradations of text, there's, Tarana text and all that, which used to be, practiced by a large number of people. And when is the main, text in a modern European language? There's only in 17th century beginning. Galileo was one of the first. Even Newton wrote only in Latin, right? Even after Galileo, Newton wrote in Latin, not in English. And Galileo, around 1600 and all that, you see, he wrote he was the first to write in these things, in Italian. And around the same time in India we have, in Malayalam there are several texts on mathematics and astronomy in the Malayalam language. And many other places also, where there are texts, on not very, maybe great works, but certainly explanatory kind of works and calculation manuals in the regional languages. So that is also an important feature. I think I will stop here. Thanks a lot for the very patient audience.
Thank you so much, sir, for your thought-provoking session. Now I would like to request Mr. Vineet Wirtz, Vice Chairman, sir, and Mr. Uday Vijay, sir, Professor of Practice at WIPS TC, to present a token of appreciation. Sir, please. Thank you, sir.
Yeah.
Now I would like to request Professor P.C. Deshmukh, sir, to deliver the concluding remarks of the day 1 of the symposium.
What an amazing day this has been. Let us give a big hand of applause to all the speakers. Incredible talks. I'm sure we all had goosebumps all through the day. Some of us who are in the 70s went to school long back, went to college long back, got into academia or some of the professions, taught for decades mathematics, physics, and related subjects. I suspect that many of them might feel the same that I am feeling now. I want to go back to school. I want to go back to my first standard and begin to learn what merits learning. We learned so many things and did not learn what was our heritage. I mean, just now Sriram mentioned that, okay, means we talk about Newton and Leibniz, and here these people knew it 500 years before Newton. Means the idea of a limit, the idea of a derivative, you can't do any science or any engineering, any technology without these ideas. And these ideas were developed right here. There is a very famous 3-man paper in quantum mechanics written by Heisenberg, Born, and Jordan. But the 3-man paper, which impacted me personally, was written by Ramasubramanian, M.D. Srinivas, and Sriram. This was 30 years ago, more than 30 years, I think.
Around 1994, yeah.
Yes. And I must confess that I was not smart enough to understand all the intricacies. But what I learned from that paper, and which certainly influenced me in a very big way, was the kind of research they carried out. Extensive research which most of us would not even touch, thinking that it is not accessible. To get into those details, this was amazing. And I'm really very happy to share this very personal thought that it inspired me to understand what research really is. My mainstream research remained in a different area. I did not get into the studies of the Kerala School of Mathematics, which I always respected, admired, but did not study personally. But I studied something else. I was studying atomic physics. But that you get into the roots of a problem, go to the original literature, study it thoroughly. This is something which I learned from your papers. Thank you very much. We have had a great day, and we have another one coming up tomorrow. Professor Bhushan Patwardhanji, he brought about a very fundamental idea. Means we all know, everybody in every Bharatiya family, we recite Om. And how fundamental it is to understand genetics. This is amazing. I think this is the book which we are all going to learn from. Professor Mahadevan is, of course, everybody listens to him on the YouTube, his talks, his book is so famous. And what a privilege it has been to listen to him in person today. He emphasized the importance of validating knowledge, which is really extremely important. And so much of this is happening now. I think all of you scholars over here, you have contributed so much to it in the last 3-4 decades. We are talking about the movement in Bharat in the last few years. But this is the collective work of many scholars, most of whom are with us today over the last 3-4 decades. It's not something which has happened in the last few years. It is only coming together now. We have had great talks. Dr. Sudarshan Iyengar made such an interesting presentation, pointing out how you go about studying difficult topics, using storytellings, and how these things are so important. The need to bring out fresh editions of classic works. How important it is something that sometimes we realize when we get a photocopy of some paper and read from it, and then we find that there are missing links and we cannot figure out what's going on. And how these missing links are to be reinvented, perhaps reconstructed. Professor M.D. Srinivas, I have always enjoyed listening to you, talking to you. It has always been a privilege, and you brought out the contributions of the Kerala School of Astronomy, you and your collaborators. We have had awesome talks today. Shekhar Mandey, his distinguished father, Chintamani Mandey, was my PhD thesis supervisor. And I was addressing Shekhar as Shekhar. And that's for a good reason, because I've seen him as a very young boy in high school. He once made a nice pinhole camera and was showing me how the image remains the same even if you turn the box upside down. It was amazing to get the kind of evidence. Means sometimes we hear about people making claims that, okay, hamare paas ye tha, wo tha. But all the scholars today, they presented their conclusions with very robust validation. Like Shekhar talked about the dental surgery, for example. Every other work today, measurement of length and time, there is no physics, there is no science without it. And how these calibrations are done, means I heard your talk some time back earlier, Dr. Avinash Chandraji. Very exciting research. Because one of the first things a scientist or an engineer learns is how to carry out measurements and how to calibrate your observations. Because without that calibration, your measurements have got absolutely no meaning. It is very complicated. And to figure out how this was done so accurately through literature which most of us are not familiar with, I cannot imagine how much effort you have put in this and how many years of effort must have gone into this. This is incredible. It is, means even after reading your article, even after listening to your talk, it would take several weeks and months of intense study to understand this. And how you figured this out from literature, dug into the details, it's really amazing. I think all our future generations of scientists and engineers will be very grateful to you for this work. This has been a great day. This has been a great day, and very distinguished scholars have talked to us. We have volunteers in this hall who have taken notes throughout the day. I'm very grateful to all of them. They are going to assist us in generating transcripts of your talks. These are student volunteers, faculty volunteers. They're all working under the inspiration of Dr. S.C. Vatsji. Nahi? See, we visit so many institutions, but we don't get this kind of support. For faculty members and students to sit through, take notes with a commitment that, okay, these things, these transcripts are important so that we can bring out the proceedings from which students and others will continue to learn. That kind of inspiration and dedication you don't see in many educational institutions. We have it at the Vivekananda Institute of Professional Studies. Thank you very much. Very grateful to all the faculty volunteers, all the students volunteers. Many others have contributed to this beautiful day, to making this day so beautiful, so powerful. I think it is going to have an impact on education in this country. in a very big way. It's not just one event. I am fully convinced that it will make a significant impact on the way education is imparted in our country, in colleges and schools across the country. Of course, many of these scholars have contributed to the NEP. NEP has come up because of the contributions of many of the scholars who have talked to us. But this event in which, they have come here and told us about their research, it's amazing. We are going to have another wonderful day tomorrow, so I'm sure we will all assemble for that. I believe we are going to have a short break, but we are going to reassemble for a very exciting event. And we have a great scholar with us, Sri Ravi Ayarji, who will be telling us about Vedic mathematics. And that is, how large the knowledge system is. This is amazing. We have had a rich set of talks, and we are nowhere close to, even looking at just a part of it. So we are looking forward to your talk, Ravi Ayarji. We are very privileged to have you. Are we having a short break? Bharati, would you like to make an announcement about it? Yes.
Thank you, sir. Now I would like to request Mr. Uday Birje, sir, to present a vote of thanks.
Namaste and Jai Hind. Respected Chief Guest, Dr. Bhushan Patwardhan ji in absentia, our keynote speaker, Professor Mahadevan in absentia again, Chairman, Vivekananda Institute of Professional Studies, Dr. S.C. Vats, Vice Chairman, Sri Vineet Vats, Vice Chairman, Sri Suneet Vats, esteemed speakers, dignitaries, participants, faculty and members of the organizing committee. I come from down south, the state of Karnataka, or known as the state of Mysuru earlier. The land of great temples, mutts, palaces, institutions, scholars, enlightened spiritual gurus, and Maharajas who contributed significantly to the idea of Bharat. The relationship between Mysore Maharaja and our greatest modern philosopher, Swami Vivekananda, is well known. VIPS is one such institution that has adapted the principles of Swami Vivekananda. It's a proud privilege for me to be standing here in front of a galaxy of scholars and distinguished guests to propose the vote of thanks. On behalf of Vivekananda Institute of Professional Studies, Technical Campus, I extend my heartfelt gratitude to everyone involved in making the Symposium on Bharatiya Knowledge System a resounding success. This symposium is the culmination of more than a year of meticulous planning, tireless efforts, unwavering commitment, and most importantly, the vision of our Honorable Chairman, Dr. S.C. Vats. It is pertinent for me to mention here that the inspiration and encouragement to use technologies like artificial intelligence in the academia and innovation ecosystem for BKS has come from none other than our Honorable Prime Minister, Sri Narendra Modi. I've been using this short video almost everywhere across this country, and possibly here also you may have seen it, some of you may have seen it. Here's a short video which should inspire all of you, because we have the support of the highest authority in the country. And we have seen that in the last 10 years, how much the ecosystem has been energized because of the leader in our country. Here's a short video. This video was about from December 2023, a 1-minute video. I think it's worth playing this, even if somebody has seen it.
भाषा में डिजिटल सर्विसेज कैसे उपलब्ध कराई जा सकती हैं, इस बारे में भी सोचें। जो भाषा अब नहीं बोली जाती, उसे एआई की मदद से कैसे रिवाइव किया जा सकता है, इस पर भी काम करें। संस्कृत भाषा का नॉलेज बेस और लिटरेचर बहुत समृद्ध है, उसे एआई की मदद से कैसे आगे बढ़ाया जा सकता है, इस पर भी सोचें। एआई की मदद से वैदिक मैथमेटिक्स के मिसिंग वॉल्यूम्स को क्या फिर से जोड़ा जा सकता है, इस बारे में भी प्रयास किया जाना चाहिए। फ्रेंड्स, मुझे विश्वास है कि ये समिट आइडियाज एक्सचेंज करने का बेहतरीन अवसर उपलब्ध कराएगी। मैं चाहता हूं
This video almost looks like a message to all of us here. And if you see all the right messages you have got here, missing volumes, and I would urge all the scholars here who are present here and also tomorrow to explore the possibility of using artificial intelligence to restore and revive and energize the ecosystem so that we can move faster in the journey towards implementing Bharatiya knowledge system. The possibilities of Bharatiya knowledge system have been significantly enhanced due to the visionary thoughts of our Honorable Prime Minister. We are also delighted and thankful to have Hanuman, who will be talking to us tomorrow, a multilingual LLM and sovereign platform, to participate in this symposium to enlighten us as to how AI can be used to build awareness faster and wider about the Bharatiya knowledge system. To our keynote speakers and panelists, your insightful presentations will enlighten us today and of course tomorrow on the vast experience of Bharatiya knowledge systems. Your expertise will inspire us to delve deeper into our rich heritage. To our esteemed guests, we are honored by your presence. Your contributions to promoting Bharatiya knowledge systems is invaluable. To the members of the organizing committee, volunteers, VIPS team members, your tireless efforts have created a seamless, fantastic experience. Your dedication is commendable. I can't take so many names. I think everybody has gone out of the way to help to make this successful. I have no hesitations in saying that the VIPS Bharatiya Knowledge System Symposium is the biggest gathering of scholars nationally ever done. So I would like to extend my deep gratitude to Dr. P.C. Deshmukh ji and the organizing team members once again for having carefully chosen the most experienced scholars and for having invited them to be a part of this VIPS Bharatiya Knowledge System Symposium. This symposium has rekindled our connection with the BKS's timeless wisdom, fostered meaningful discussions and networking, encouraged interdisciplinary approaches. As we conclude the first day, I'd like to highlight that through this platform, we propose the industry, academia, policy-making organizations from the government to officially rename the Department of IKS as Bharatiya Knowledge System. Sir, for all the government representatives here, you must take it up. We would like to also propose that all the government and private institutions, I see IKS being promoted only in some IIMs and a couple of IITs, and I have no hesitation. Possibly VIPS is the first private organization to have taken up this. Yes, and we would like to propose that all the government and private institutions to integrate BKS into our education and research, apply its principles to address contemporary challenges of Bharat, and promote cultural understanding and exchange. We look forward to continued collaborations and with the support of all the members present here to make the BKS at VIPSTC an annual event, sir. to deliberate promotion of our rich history, heritage, culture, scientific discoveries, and practices. In Mysuru, we just concluded the world-famous Dasara, which is actually a celebration of the good over the evil. The blessings of Devi Chamundeshwari. May Goddess Chamundeshwari bless you all with immense happiness, success, and prosperity. Thank you once again for your presence, participation, and contribution. Dhanyavad, Jai Hind, Bharat Mata Ki Jai. So there is one lost formality. I think this country lost a gem. I think we all decided that we must have a small tribute to Shri Ratan Tata ji, because almost 1.4 billion people of India, on everybody's lips, Tata has been there. So I think let us do that. Thank you, Team VIPS. Fantastic short video. And now I'd like to request everyone to stand up for the national anthem, please.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
बोलो भारत माता की, भारत माता की, भारत माता की, वंदे वंदे वंदे. Thank you very much. See you all tomorrow morning again at 10 o'clock.
Faculty members and students and guests all are requested to join us for a high tea at CAI Hall for faculty and students, and then after 20 minutes of break, we'll meet at Seminar Hall for workshop on Vedic Maths.